Well, hello there. This is Mel McGee. I'm with We Can Code It. I'm the founder and CEO. I am also a software developer. I've been a web and software developer for about 25 years now. Let me help you out here. We're going to learn about test-driven development, and we're going to do some fun exercises. It's going to be pretty simple for you. And we're going to start with Legos, and then I'm going to drop you into what's called Jest. It's a framework for testing with JavaScript. And we're going to make some what are called unit tests there. But we're going to start with the background first. So what is TDD? It is a process, and it's more about design than it is about anything else. You're trying to create a well-designed piece of software. And so what we do is we do this through, we're going to start with unit tests, and these are very short development cycles, right? Right here, we have requirements that are turned into very specific tests, and then we write the code to pass the tests and the new tests only, while still passing all the other tests, right? So it's a really good practice, and it helps us stay organized, think out our code, create self-describing code. It's sort of like, and nobody ever gets this, but I'm going to teach you something new today if you don't know it. It's like mise en place. So mise en place is a practice that chefs use, and you have your items all chopped up and organized and the like, and it makes it easier, and it makes your code or in that case, a meal more replicable so that the quality is always maintained. Well, that's what we're trying to do here, in my opinion. So let's start back by why we all form such bad habits, at least what happened to me when I was in school. So I love this, do you have an idea for your story? No, I'm waiting for inspiration. Last minute panic, right? That's the mood. So we don't want to get into a place where we're panicking, trying to finish the end of a project, throwing it together, and getting sloppy. So let's take a look. How we form bad habits. I hope you like my artwork. That's why I'm a developer and not an artist. So you're in class, hey, have these problems done. Not a problem. Breeze, easy peasy. Okay, write a program that takes in a list of numbers and returns only the even ones. All right. Okay, we might use mod here, mod 2. Okay, that's even. All right, not a problem. So, woohoo! Good. Number mod 2 is 0. Good. Looks tested. I wonder what my friend's up to. Then we go, we start surfing. Look at the cat. Oh, what a cute duck. Order some insomnia cookies. Oh, then we're trying on problem 2. And all of a sudden, we have 3 hours left till class, and our program looks like this. Holy Moses. Yes, I have written things like this before. Not the prettiest, and you could just look at it. And when you look at it, do you know what it does? Because I don't, and I'd have to go, oh my gosh, okay, var. Start at the beginning and really put some energy towards understanding this. It's not readily apparent, and it creates a little bit of chaos in my mind, right? I have to clean it up when I input it mentally into my head to understand what's going on here. So that's called spaghetti code, folks. This is the valid measurement of code quality, right? Good code, a couple of, what's going on? Bad code, people are just pulling their hair out. What is up with this code? And maintaining this is a nightmare. I don't know if you've ever experienced it, but I have, maintaining somebody's code and it looks like the previous example. What do we even do? Do we tear this down, start from scratch, try to rebuild it, try to work with what we have? It can bring down a whole application. But you'd say, well, it works. Okay, if I'm just writing spaghetti code and trying to get something to work, that's fine. That's fine. I'll say that. It works for small projects, great. if it's my own personal project, I'm really not going to touch again. It's not really found in the real world. It's not, nobody else is using it. Not a problem. It works. However, the more people and the larger code bases you have, this thing gets complex. It gets complex. And with complexity, we have bugs introduced. And there's actually something that measures this. It's called cyclomatic complexity, right? And every time there is a condition here, the code becomes more complex. Now, every time you have more complex piece of code, the more bugs can be introduced. So we have the spaghetti code. We're not thinking about how we're writing it. We're introducing maybe a lot of if-else statements that might not have to be there. And then on top of that, let's put a switch with a case here. Wow, okay. Confusing, and then let's throw on top of that a loop. Holy Moses, we're looping over this over and over with all of these possible different paths for the code to take in here. It's not clean. It's not self-describing, and it multiplies this when you have more developers working on a project. The project gets bigger. Bugs could be introduced at any of these points. Okay, let's add one more thing to this. So how does this all go awry? How do we make spaghetti code? Well, then we have waterfall project management. So you're out in the real world now, and somebody's telling you, you will get this done, and you will get this done by this time at this date. And so, you know, there are 300 of you. I want you to finish by 5 o'clock, clean out your desks. You're all fired. Right? We know that could be the real world if we're working with waterfall management that is telling you when to get things done, and you're like, I can't do it. So you get freaked out, you get sloppy, and you get into the habit of get this done now. And we're back to the old habits again, right? So it creates a recipe for failure, and not a very tasty one either. So what do we do instead? So let's test the code, right? So this is called test last development. Testing isn't all about test-driven development. There is also test last development, but here's the deal. Programmer's writing the code at this point in time, and then you have a tester, a QA tester, and they're irritated because the tests aren't passing and shoving it back to the developer, and it's a cycle of it compiled and it didn't pass. And it's frustrating, and it's not very efficient, right? So let me back up a second and say, what does a test do? It acts, you know, as an input to the program's method or functions. It tries to act as a surrogate, right, to your code, as if it were a user. The test is acting as that user and running things. That's all it's doing. It's telling you passed or didn't pass. That's all it does. So if we go back here again, our QA tester is doing this and missing deadlines. Everybody's upset. Code doesn't work. You have project managers using waterfall methodology telling you must be done by this time. You don't have much saying, and it's just a mess. And let's look at this. There is a better way, and that's TDD. It is a design practice, okay? It takes tests and puts it back into the developer's hands, and developers are responsible for thinking through problems in depth versus hacking out code to get it off their plates, okay? It encourages decoupling, modularization. These small units can be designed, developed, and tested regardless of where they're used. So how wonderful. Modularization is such a good thing. We can reuse code. How cool, right? And the code is actually easy to read. So our whole purpose of TDD is to bring thoughtfulness and discipline to development. And Bob Martin, sort of the father of, or uncle, I should say, of clean code, says The act of writing a unit test is more of an act of design than of verification. Okay? We're designing our code as we go along, as we write these tests. So it forces us to think about our code. Okay, everybody's happy at that point. Fewer bugs. Woo. Other people are looking at the code saying, I could actually read this. And businesses are thinking, sweet, things aren't over-architected. It's doing what we want it to do, and hopefully has money ideas factored into here where you're not wasting time on writing or maintaining code. Got it? Okay. Look at this. Clean code does one thing well. Just one thing well. What does that mean? Well, it means that your code should be self-evident and small. Make lots of small, understandable functions, really. Don't make a whole bunch of loops and conditions and shove all these things into one massive function. Okay, just keep it really clean. Logic should be straightforward. So there are some meta-analyses, whatever, on TDD, not many. One showed that it yields more benefits than testing last, but productivity is lower. So it takes longer, really. It does take longer in the beginning, but the quality is higher, is what these folks came up with. I think quality is higher, and personally, yeah, it does take longer to write a test and then have the test pass, but I will put some effort up front to do that if I know I'm on a serious project, so that at the end I can maintain it much easier. Okay, so what did I learn from this? So I'm founder of We Can Code It. How did I put this into practice in coding school? Well, I have learned to teach people this from the start. Because it is hard to teach an old dog new tricks, right? It is hard for us once we're in a groove of this is how we write code to switch from that and start using TDD. We're not used to it. So especially when you're under a deadline, how are you going to learn how to do TDD? Well, hopefully, if you have bad practices, maybe you'll come out of this more interested in TDD and find a little time to do a passion project on it and add it into your code. And otherwise, at least you know about it, right? Can't say you won't know about it. Advice from a graduate actually likes it. Yay. Maintain a consistent pace of development. That's a big part of it for sure. Okay, let me show you some of these folks in action. So, programming does not have to be a lonely process. Even now that we're all remote, we can use tools online to work in pairs and talk things out with folks as we're doing test-driven development. So I just wanted to show you that. I thought this was a cute time-lapse video. So let's look at the essence of TDD here. Let's start breaking this down. TDD is writing enough code so it runs, thinking through how we test the code, and writing just enough code so your test passes. Okay? This is not JavaScript, but I think you get it. We're looking at Java here. And Java uses JUnit. We're going to be looking at Jasmine. Jest later. And I just want you to look at this code and compare it mentally. We'll look at that in a second. Look at how clean this is. These little methods. Very simple to read. And here are the tests that go with methods. Nice and clean. Let's take a look. This versus this, right? Now these aren't doing the same thing, but you can see the mental load for the code on the right side is just obviously a lot lighter than looking at the left side. This makes sense. Now we're going to go ahead and actually put some of this into practice using Legos. After that, we'll jump into doing this in JavaScript using Jest. Okay, so this is how you think of writing tests. We start with red, write a test that fails. Then we want to write just enough code for the test to pass. And then finally, before we go on to the next test, we refactor. And that isn't necessarily fixing bugs. That's part of the green pass part. Refactoring is improving the quality of code. So maybe my variable's named a weird thing, right? We might want to refactor that so it's cleaner. So red, green, refactor, and we repeat. So we always fail first. Remember that. Do not write any production code without writing a failing test. You want to watch a new test fail before you try to make it pass, okay? That's a goal. Failing is a goal here. Then we simply pass the green test. Simply, we write easy, simple code to make the new test pass. Sometimes that means initially just returning some kind of static value, right? Some kind of static value could be enough to make that thing pass. And then finally, you clean it up, refactor. That could be removing duplication, ensuring naming is well thought out. This is not where you change the behavior of the code, okay? That requires a new cycle. This is just cleaning up little bits and pieces that are messy. It's like cleaning up after yourself, okay? All right, here we go. So we are going to be the developer. Even if you're not a developer, you can do this. If you have a Lego set, bring it out. If you don't, what we're going to use is, let me try to find this. It's a website I found. It's called Mecha Bricks, M-E-C-A Bricks. Let's pop this over here. Let me show it to you, mechabricks.com, and it's fine, let's leave just to show you what this looks like. You go here and simply hit Start Now. Okay, and it brings you here. It's relatively intuitive. Let me throw a couple of things up here so you know. Let's say I want to select this brick. I can move it around this 3D world here, left, right, and then if you wanted to move it up or down, you could do this, okay? That's all you have to do. If you wanted to add another brick here, you could. Notice it pops it right in the middle, so it's not like I'm a pro at this. I just found this moments ago, so I can help you with this, but I think you get the idea here. You might snap it into place and the like, but I'm just moving it around like that. And for all intents and purposes, this should serve us well. Okay, so we're going to use these. I'm just going to refresh it here. Refreshing it will clean my palette. Good. Okay, so head over there, and here's what we're going to do. You have 1 minute to build a person and a house with your Legos. Go. I'll do mine here. Let's see, a person in a house. What might that look like? Ooh. Let's see. So there's my house. Let's add a person. Not a real good looking person, but there's a big head. Okay. Okay, I'm done. You have a few more moments. If you want to pause this and continue, you can, but given that this is remote, it doesn't really work the same, right? as if we were in person. It's a little funner in groups, just saying. Okay, so curious what you came up with. Let's take a look and see what TDD says about this. So, are you proud? No, I'm not very proud of my build. Are there imperfections? Absolutely. Could it be done better? Absolutely. Is this a quality person in-house? I'd say not. And if I asked you to switch out different aspects, would it be simple for someone else to do quickly? Yeah, I think that one I could say. So, all right, that's cool. Let's clean our Lego area, and let's start with TDD here. Let's open up Mecha Bricks, and I'm just going to refresh. So that's how I'm cleaning out my area. Okay, let's fail this test. Okay, house and person. Let's do one first. Let's do a person. Okay, did I fail? Do I have a person? Here's my test. Fail. I don't have a person. I failed. Yes. Very good. Okay. So you want to fail first. And then we celebrate. Okay, now let's go green. What's the minimum we need to pass this test? What is the minimum? And let's pop over to Mecha Bricks here. And let's think here. How can we simply pass a person test? How about this? Is this a person? Got to think abstractly. What does somebody mean by a person? You have a client out there, right? Your client's saying, I want this a person to be represented. You didn't necessarily ask for the Mona Lisa, you know? It could be a stick figure. Is that a person to them? Let's start simple. Let's pass this test. And yay, we passed the test. That's what I'm saying. I'm calling that a person. And then refactor. Is there any duplication here? Is there any duplication? And no, there's no duplication. Nothing really cleaner and simpler than one little Lego block. I mean, I wasn't asked to do anything else. I just was asked to represent a person. So that's all we need. Now let's do the same process with the house. Let's do first step, second step, third, right? Red, green, refactor. So we have our person. Cool. Now let's add a house. Good. Object added. Let me move it over here. We don't have to move it over here. Okay, so we had red. We didn't have a house. Now we have green. Celebrate. Right? And then refactor. So if there isn't a house there, you've passed the red test. Could look something like this, depending on your language. Then we just do the minimum to pass the test. And we look for anything that is really just gonna messy and that we have to clean up. Red, green, refactor. Now, if you're saying, well, why didn't you build something more, Mel? What's going on here? This is part of the heart of why we keep things simple. What if, let's get to this one. We had a client, like I was talking about, and we now know that each dot on a Lego costs $1,000. Let's look. Did we over-design here? Oh man, this has 2 dots. Is there one with 1 dot? Let's see. Let's see. Let me refresh this. And now I'm thinking differently, right? And that's how I want you to think, because that's really the situation. We had a red, now we have a green. It's $1,000 versus $2,000. Let me add a house. That house is now $1,000 versus $2,000. We just saved a good bit of money. This is simple and minimalistic, okay? So conceptually, that's what we want to be thinking about here. So did we over-design? Yes, I totally over-designed. Knowing now that larger blocks are more expensive, customer probably wouldn't have been happy. that we started programming on his or her dime without knowing these requirements. And using TDD, we're delivering the best bang for the buck, ensuring that we write maintainable, small, and reusable code. All right, a new test. Can you fit your person into the house? Can your person fit into the house? Fit in is touching on 3 sides. I want you to go ahead and try this. So we're going to start with red, go to green, and then refactor. So I'm headed over here. Can my person fit into my house? Touching on 3 sides. Let's take a look. I'm going to zoom in here. Move this guy. Well, I can get him to touch here. So no, I cannot get him to touch on 3 sides. So we need to redo our house a little bit. We need to add on to our house. And I'm going to try to do this in a way that is inexpensive. This one looks pretty good, right? So let's remove that and see. This touches. We need another Lego here, and we're going to have to flip that guy around. That might do the trick, huh? Here's our person. That's 3 sides. If I move it up to the same, there we go. There we go. And voila. So I had, it wasn't passing, then I went through, that would be the test that fails. Then I wrote my code, right, or made my Legos to make it pass, and test it again and say, yes, it touches on 3 sides, and it suffices to pass this test, and I don't see any duplications, so yay. All right. Here is where I want you to learn how to write your own tests, because honestly, this is a big part of TDD. It's writing tests, figuring out which things to test. So sometimes you can do this on your own. A lot of times you're going to need the help of your client or your buddies or whatever. So let's pretend, let's say we have our first options here. We had a person in a house. You talk to the client. Client said, okay, the person needs to fit into the house. Okay, what does that mean? It means touching on 3 sides. Okay, got it. Now we've passed that test. But now the client wants a tree, an animal, a vehicle. They're throwing all these things at you. This is when you talk to them. Okay, let's talk about the tree. What does the tree look like? And honestly, this is where doing agile kind of development and that kind of project management, dare I say, fits in really beautifully with TDD because you have conversations with the product owner here, so you can actually communicate with this person and say, tell me about this tree. Is the tree bigger than the house? Oh, yeah, the tree is bigger than the house. Okay. Does it always have to be? Yes, I think the tree always has to be bigger than the house. Okay. What about the, what about an animal? Yeah, I want the animal. The animal needs to be smaller than the person, though, and definitely fit in the house with the person. So now you have tests like, is animal smaller than person? Does animal fit in house? Do animal and person fit in house? And you're going to redesign your code as you go along, right? Because now we have an animal and a person that need to fit in the house. You're going to have to make the house bigger. But, keeping all of the other concepts in mind that we've already gone over, like we don't want to over-design here, but we want to design just enough. And it's that kind of editing that does take a little while, and I think it's probably a pretty tricky part for folks. So how do we do this? So if you start writing these tests, I really encourage you to do this and think of other examples you can use here to come up with additional items. But part of this is just practicing, stretching your creativity, and your logic skills, honestly, and keep practicing it. So here are some tips for coming up with tests. So first of all, just start with any example, okay? House, bigger than person, touches on 3 sides. Can I go simpler than that? Maybe not. Maybe I'm saying the house is, 2 people need to fit in a house is more complex, right? I could say all of these things. I could say a tree in the house and the person need to fit inside a plot of land that is 50 by 50. We could do that, but how can we make that simpler? Okay, person fit on plot of land, house fit on plot of land, tree fit on plot of land, person fit in house. That's sort of the methodology here. Then you try to make it go to the bare minimum to make it pass. You find the kernel of this, okay, the very smallest you can. Try to complicate things a bit after that, perhaps, and continue to think of different cases. So, I want you to try to use those techniques, and you don't necessarily have to go in that order, but that's a way to get you thinking about tests here. How do you do this? What are different combinations I can make here? And am I making too many combinations in one test? That's another problem I see often. But try to keep them all simple, and we want them all to pass. And the more features you add, the more tests that are going to have to pass. Like a house, we might say an animal and a person need to fit in the house. Now you have to redesign your house code to make the house a little bit bigger than that, just fitting for the person, but not too big, right? So you finagle your code right here, and there is a nice balance eventually. So we want to keep our unit tests small, okay? We don't want a whole sloppy test code either. So keep it very simple. Test one thing at a time. Test one thing. Do not say, does house, person, tree, and animal, do they all do this one thing in one method? Okay, you don't want a test method that tests all your code. You want different, simple methods testing different, simple conditions. Good? When it comes to refactoring, we haven't talked about this a lot because we've been working with very, very simple structures here. However, the concept about refactoring is we don't alter the behavior of the code. So this is not like the place you're going to say, oh, wait, I need to expand my house. That's not the refactoring stage. That's another cycle. Refactoring is like, oh, wow, that house is labeled something odd, or maybe I have an extra Lego block that I don't need, in removing that. But it's not where you fix bugs at all. Okay, so just to sum this part up, what did we learn playing with Legos? Well, we learned that test-driven development provides structure and discipline to development. It creates higher quality code. It was more edited, simpler, beautiful code, right? It's agile. It's part of agile development. I've mentioned that learning it from the start's a lot easier than learning it as you move along, at least in my opinion. That's why we teach it. Ultimately, it creates higher quality products, and it saves folks time and money, at least in the long run. It might be a little more taxing at the start if you're just trying to get something done. But in the long run, especially for larger projects, it keeps things nice and clean, saving people from wasting valuable resources. All right, next up, we are going to get into Jest and JavaScript and write some tests and actually try this out for real. It's for the developers in the group, and if you're not a developer, that's okay. You can watch too and maybe pick up a few things. So I'm going to be opening up VS Code, and working from there. So go ahead and get your favorite development environment going. VS Code is what I'll be using. Alrighty, so we are going to use test-driven development with JavaScript and Node.js. I want you to have Node.js installed here. And we are going to be using a testing platform, a very popular one called Jest. So Jest is the platform that helps you create the tests, run the tests, and the like. We are going to be doing what are called unit tests. I don't want to throw a whole bunch of jargon at you. However, there are three main categories of tests. One of them is unit testing. Then there's also integration testing, and then user interface, UI testing. Okay, we're just going to look at unit testing here. And we are going to be creating FizzBuzz. So if you don't know what FizzBuzz is, go ahead and look it up. Basically, it's a game. There are two numbers. In this case, we're going to be using 3 and 5. And every time a number, you start with the number 1 and you count up. If I hit something that's evenly divisible without a remainder by 3, we're going to reply with fizz. If it's divisible by 5, we're going to say buzz. And if it's divisible by both 3 and 5, we say fizz buzz. So if we're playing together, you'd say 1, I'd say 2. It would come back to you for 3, and instead of 3, you would say fizz. Come back to me 4, go back to you 5, and instead of 5, you'd say buzz, and so on. When we hit the number 15, it's divisible by both 3 and 5, we'd say fizz buzz. So I hope you get the idea of what FizzBuzz is. We're going to make this as a development project. You'll want, again, Node installed. I'm using Git Bash terminal here. Your terminal may vary. I'm in my code folder, and I'm going to start here from scratch. I'm going to make directory, and I'm going to call this FizzBuzz. Pretty simple, okay? And there's my directory. I'll cd into it. Oops. Let's try that again. There we go. And then I'm going to use npm, Node Package Manager, and we're going to hit a -y here. And let's get our project established, and you'll see it created a package.json file for us, which we'll edit in a second. All right, we're going to install Jest next, and we just go npm. Jest, and then we're going to save -j here. All right, and let's wait for that to happen. And again, I'm going to be using Visual Studio Code here. So it's free. I like it. I think it's a good interface. You might want to install, they have different add-ons. And there is a pretty cool Jest add-on you can add for our purposes. So you might want to do that. That's an extension here, and I'll show you that in a moment. So anyways, we just did that. We're good to go. And one more thing I want to do. I want to make a directory called tests. This is expected from Jest. Here, this is how we're going to do it. We're in the FizzBuzz directory right now. So I'm going to make directory, and it goes __, tests, __, boom, get that out of the way. So we've set this up, and I'll create a test file when I'm in Visual Studio Code. So because I'm on Windows, I can just call code, which is Visual Studio Code. We're basically saying execute this. In the current folder. So I'm opening up the current folder with Visual Studio Code and open on my other window. I'll drag it over here. 1 second. Here we go. All right. Let's pop this up and let's pop up Git Bash so you see it over here. All right. I don't need this welcome screen. I do want to update package.json. So let's go ahead and click that. Right here it will say test. Now we need to change this to Jest. We're saying we're going to be using Jest. okay? And I control the S to save it, and so far so good. Okay, next up, we want to go into our tests folder, and we are going to create our spec.js, which is our test file, okay? The spec, which you'll see in a second, is something they use in Ruby a lot and just sort of got ported to the just tests here. So let's call this fizzbuzz.spec.js. Okay, this is going to be our test file. And remember, in test-driven development, we start with the test. Oh, I did tell you, I was going to show you about the extensions, right? So let's find extensions here. You can search for just, and I already have it going, but you can install it here. It will allow you to test within your Visual Studio Code project. So it's this one. So I already have it enabled. Lots of other things you can play with here, but we're not going to go into. Okay. Fail first, right? This is our test. We're going to fail first, and here's how we start it. We're going to start our first just test. So we're in our fizzbuzz.spec.js file, and we're going to start with our test block here. And we start out like this. We describe something, right? And what are we describing? Well, let's describe the fizzbuzz function. Sound good? Makes sense, right? Fizzbuzz function. Cool. Now, we're going to have a callback. So in a callback, this is going to be anonymous. So it looks like this. Hopefully, you have some coding experience here. And I'm just going to make it with a pretty like that. All right. So we got that down. And so we're set up here. And real quick, I want to talk to you about what actual tests look like. So before I get into it, every test is going to look like this. There are multiple different ways to do this. You might see other tutorials doing it differently, but this is pretty standard. So let's do this. What should it do? It should return fizz when divisible by 3. Let's start that as our first test. Does that sound good? And then our second parameter here is going to be anonymous callback. So rocket, boom. And here's where you write your test. Okay. Before we go out and talk about writing our first test, I want you to think of 3 things in a test. It's input, output, and assert, or the function. Okay? So we need some input for the test. In this case, we want 3 to return fizz. Okay? So let's go ahead. Constant input equals 3. All right. And what do we expect? Let's do that. Let's make a constant called output and assign it to fizz. We want fizz to return, right? Good. Now here's where we write the expect or the assert. So instead of assert, let's say expect. Input, output, expect, okay? So we expect what? We expect this, the input to a function we call fizzbuzz to come out and say fizz, right? A little weird, but let's try this here. I'll just show it to you. Expect, and we're going to make this, but remember we haven't made this yet. Fizzbuzz, that's our function. And we're going to pass in the input. In this case, input is 3, right? And we expect that to equal output. Be mindful of where you're putting your parentheses here. Expect starts and ends there, and then we want it to equal output, okay? Good. So let's start. Let's see if we can get a failing test. I'm going to Control S to save this. And I have, because I have that extension here, you'll see that it's red and it says, FizzBuzz is not defined. Well, yeah, congratulations. We made our failing test. Just to show you another way to test, all you have to do is, let's see, NPM tests. Let's just do it. NPM test. And voila, one failed out of one total of the test suites, and one failed out of one total of the tests. It tells us other information. And test failed. See above for details. And it tells us right here, FizzBuzz function, it should return FizzBuzz is not defined. Okay? So, and it tells you where. But you can also see it here if you have that extension set up. Now, typically, we'd want the test and the source, our code, in two different files. For our purposes here, I'm going to just put it in the same file so you can see it, and it becomes a little simpler. And you can learn about exporting and linking those up later. And maybe I'll create another video for you on that. For this, though, let's just keep going. So we have a fail, right? So what do we need to do? We need to now make it pass in the simplest way possible. So let's write our code here, our development code, not our test anymore. Let's make the function FizzBuzz, right? All right. And what is it? It receives input. Cool. And what's the easiest thing we can do to make this pass? Think about it from the Lego portion of this. How about returning Fizz? Right? Weird, huh? But guess what? It's all we needed to do to pass this test. This is how you do it. Okay, cool. So don't worry, don't get in the future yet. We're just going to take this one step at a time. It's all about staying in the present here, okay? Let's make another test, and you see I'm copying and pasting, and many of you might be yelling at me bad practice, but it is what it is. I'm trying to make this quick for you. Now let's do another test. It should return buzz when divisible by 5, and let me get rid of these comments. Getting rid of comments could be part of my refactoring, by the way. Forgot to do that, huh? All right, it's all good. So in this case, we want buzz to be divisible by 5. So let's put input of 5. Buzz is going to return when it's divisible by 5. And let's put buzz. That's what the expected output. This can stay the same. Clean this up too. All right. And let's run our test and see what happens. Ooh, this passes, but this does not. And remember, you can always use your terminal down here, npm test, and it will tell you the same thing. Okay, failed. One failed, one passed out of 2 total. Okay, cool. So now we have to write the code to deal with this. And now I have to actually think, right? So let's start designing this. We're going to use mod here, right? So let's make a constant, and let's call this mult of 3, and let's set it to our input, mod 3 is equal to 0. Okay, so let's do the same thing for 5. Multiple of 5, input mod 5 equals 0. We know it's a multiple of 5 in that case. All right. So let's try to get the buzz to pass here. So let's say if multiple of 5, if that's true, then return what? Buzz, right? Well, you know this is going to break the other code, but let's do this. It's going to break our first test, but that's all right. We're going to watch it. save it, and okay, our second test passes, but now our first test is broken, so let's go through another iteration. Before I start my red-green refactor, we have to refactor. Anything to refactor here? This might not be the best name. And that's, do I want to do anything about it? Is it understandable? Do we want to change it to evenly divisible by 3? I like that a little bit better. Evenly divisible by 3, and let's do this as evenly divisible by 5, and we could just be a little weird like that, it's all right. And then let's refactor this, evenly divisible by 5, return buzz. I'm okay with this. All right, let's save it again. So we're going to go back to a next iteration. We have red. We've started with red. Return fizz when divisible by 3. And we can go over here, and it says that fizz and it received undefined. Okay. So in this case, let's write another if statement down here. And if you wanted to get really fancy, you can make these all separate functions. We're just doing it like conventionally here. If evenly divisible by 3, return fizz. Good. Save it. Let's see. And I have green. So I want red. Now I'm green. Now we refactor. Anything to refactor? I don't see it. I think it's pretty good. All right. Now we know we need to do the last part here. Well, there's 2 more parts. We have to do 5, and if it's evenly divisible by 3 and evenly divisible by 5, we want to have fizz buzz return. So let's create a new test. So there we go. How about it should return fizz buzz when divisible by 5 and 3. Okay, so let's do this. 15 would be a good input to test here, right? Because a 5 and 3 are both multipliers of in 15. 5 times 3 is 15, right? So we want 15 is a good one to test. Output fizz buzz, and expect the input of 15 to come back with fizz buzz. So let's start here. I'm going to make an intentional mistake. That's okay. Let me clean this up just a little bit. So, okay. How about this? If evenly divisible 3 and evenly divisible by 5, return fizz buzz, right? Now, what do you think is going to happen? Ooh, it didn't. But why? Well, think about it. It's hitting, is this evenly divisible by 5? Is 15 evenly divisible by 5? Yes, it hits this first. It returns buzz instead of fizz buzz. So what do we need to do here? What we need to do is take this and basically change the order of execution, right? Set that up first so we can catch ones that are both 3 divisible by 3 and 5 on top. And then if it doesn't meet this criteria, we'll check if it's divisible by 5 and divisible by 3. So let's test this out. Save it. And voila, we have passing tests. Let's go over here to Git bash real fast. npm test. And yay, 3 passed out of 3 total. Beautiful. Okay? One more thing we need to do. That is return. Let's copy this. It should return the number, if not divisible by 3 or 5, right? It should return input when not divisible by 3, 5, or 3. Okay? So let's take a number like 2 or 1 and return. So input is 2, output's going to be 2. We expect that to be the same. So here, what's the easiest way to do that? We could, actually, it's pretty simple here. Let's just return, if all else fails, return input. We're returning the exact same number that was given to us. All right, let's test it. And voila, there we go. Now, you might want to write more tests. I'm pretty sure that this is good enough. How do you know when to stop? Well, you either get bored or you're not afraid anymore. So if you're still afraid, keep writing tests. I'm not afraid. Am I bored? Yeah, I'm getting pretty bored here. Hopefully, that helped you learn how to write tests in test-driven development using Jest and JavaScript with Node. I hope it helped. I hope this presentation was fruitful, and I really hope you start playing with test-driven development in your own projects. Thank you.
Welcome everyone. Thanks for joining me for my talk today on why does code always rot? Looking at code without looking at code. So a brief introduction of me. My name is Chris and I currently work at Shopify, more specifically Shopify Plus, as a senior software developer. Obligatory, it's a conference. We are hiring. We would love to hear from you. But before I start into my talk, I want to just do a quick thank you. I wanted to quickly say thank you to the entire JavaScript and Friends organizing team and all the other speakers that have prepared talks for this conference. This is my first conference talk, and preparing it during these times has proved challenging, and I really appreciate the pivot that the team did and is still managing to bring everything together to spread some learning around. I think you all did a great job. I just wanted to say thank you for doing it. Okay, cool. So let's talk a little bit about code rot and what I mean. So most code starts with a simple problem that we're trying to solve. That problem scope kind of grows over time, and we add code to address that growing scope. Eventually, you look at it and wonder, how did it even get to the state that it is right now? Everybody's gone to a company, opened up some piece of the code base, and wondered, how did we ever let this happen? And that's what this presentation is about. I'm not going to discuss any new frameworks or any coding patterns. In fact, I'm going to go on a limb and assume that everyone watching this wants to build high-quality, scalable software that they can all be proud of. I'm sure that you do that right now in your current jobs, and you still have parts of your code base that are rotted. I'm even willing to bet that some of that code went from what somebody would deem not rotted to rotted while you were even there, which means it happened on your watch. So does that make you a bad engineer or a bad manager or a bad person? No, I don't think you're a bad engineer, manager, or person, because this happens to everyone. And I think that if we try to be a little bit proactive about it, we can try to figure out the places where and why it happens, and then maybe we can do some stuff about it. So it all comes down to this diagram. And this diagram is sort of this idea of like, it starts with your environment that you have at work. That environment feeds a certain mindset. Those mindsets drive certain behaviors that will slowly change the environment. And it's sort of a feedback cycle that goes back and forth around all this. So I once had a friend actually that worked at a large company. Excellent developer, one of the best developers I've ever met. But he was a bit of a perfectionist. And he felt that if it wasn't perfect, it wasn't actually done. I'm going to call him Fred. So Fred would go to these meetings with people where they would discuss sort of near-term future goals, road mapping, things like that. And he was still fairly new, but had been there long enough to know there was some reasonable technical debt to address. But the tech leads, during those meetings, seemed pretty confident. The parts that Fred had the most concerns about dealt with a part of the service where the main contributor had recently left. He wasn't sure if the tech leads had a plan for that yet, but the product was moving forward, people loved what the company was putting out, and everything seemed pretty good from externally in. He used to tell me that they were very results-oriented. 1 feature a week, he used to tell me. That was the goal, 1 feature a week. So after these meetings, Fred would go back to his computer and he'd pull out this little side project that he wrote a long time ago, a small web scraper for a very specific task. List the coffees that are being served today at the local coffee shop down the street. So you could run that in a little kind of terminal command. It would list the 5 different kind of coffees. And it was about 80 lines of code, give or take. He could choose if he wanted that coffee and then maybe walk the 80 meters to the coffee shop or not. But at 80 lines of code, he called it his closet code because nobody touched it. He even had test coverage for it. And he just loved how simple it was and it was like perfect. And he would always go back to that after these kinds of meetings. Just pull it up, look at the code, kind of like zen himself out. Some people look at landscapes. Fred looked at closet code. And he did this because Fred felt like nothing would ever change. So what are we actually talking about here? Okay, in the previous example alone, all 3 of these things sort of came into play. And we'll break these down and possibly revisit parts of the example I did before. So I'm going to talk about the hedonic principle, or treadmill, depending on which way you want to name it, and hedonic motivation that goes hand in hand with that. I'm going to talk about box knowledge and what that really means, and the concept of conformity in your team, especially regarding new hires. So when it comes to the hedonic treadmill, hedonic is really just a Greek term, and it means in relating to or considered a term of pleasant sensations. It's usually studied in the terms of raising the base happiness levels over time. But what I'm actually really interested in is the negative of that, the the interest, the negative side of that side of the hedonic principle. So if you take a look at this diagram here, you can kind of see what I mean. The baseline of happiness, that sort of horizontal line, you have moments in your life where things good happen, and you have moments in your life where things bad happen. But you can see that the idea around this is like the base level of happiness doesn't really change that much over time. In fact, 75% of the general population have a baseline level of happiness that isn't actually significantly impacted after even major events. Now, of course, there's exceptions to these major events, huge traumatic experiences, long-term disability that is thrust onto someone. These are things that are sort of exceptional. But even one study found that major events had a short-term decrease and eventually returned to near levels, with candidates being asked, hey, over the next 2 years, how do you think your happiness level is going to change? And the vast majority of them said they would either stay where they are now or they foresee themselves getting better over the next 2 years. That baseline happiness, sort of their general level of happiness kind of raising back up to where that baseline used to be. So just like how we can have good moments, be really like euphoric, and then we kind of go back down. Think of like the standard examples of I bought a new car, I got a raise at my job, those kinds of things. You're very happy, but then you sort of like go back down to where you were before. The same thing happens with bad things that happen in our life. We feel bad in the moment, but over time, that fades. So what does this mean for software? You're going to ask me, you're not talking about divorce. We're talking about software. You're not talking about breaking an arm. You're talking about software. So what are we actually talking about? And I can give you a concrete example. So actually, I'm going to give you 30 seconds to read this while I take a sip of my tasty beverage. I think everybody, or most people, would have had something around this happen to them in their career. That dreaded ping, that dreaded on-call ping, where everything's on fire, nobody knows what's going on, shit's being impacted, and the company's losing money, or at least losing trust with their customers. Do you remember what your physiological response was when this happened? Maybe the first, second, third, fifth time, whatever it is. I still have it happen. You know it's happened a bunch of times. Your heart rate increases, your cortisol goes up, your stress increases, your mind starts to quickly dash between all these different possible causes. You know, while you're still waking up, by the way, it's like 1 a.m. and you're groggy, and you're like, oh, could it be it's a Redis issue? Could it be a database problem? I can't. And then you start thinking like, okay, well, what could have caused this? What was the last deploy that went out? Why is it happening now at midnight? Who else knows about this? Who is it affecting? Who should we tell? Should we tell those people? What should we tell them? How far do we go down? Do we update the status page? Do we escalate it up? I've just covered the first 30 seconds of you waking up, and that's pretty negative, right? Like that's pretty bad. What I just went through here, I bet you're already stressed a little bit more just based on what I just said, and it's not even a real thing that's happened. And I haven't even asked the worst question yet. The worst question of all. Did you do this? Is this your fault? Is it my fault? So you're going to say, stop. Just stop right there, because we do postmortems, we do RCAs, this is software, and these things happen in software. You will not shame me, sir. And I say, yeah, I know. Of course you do RCAs. Root cause analysis, by the way. Of course you do postmortems. I mean, everybody does this, right? Okay. But maybe we're talking about two different things. What if you're driving your car and you actually take a turn too wide and you go into the ditch? See, there's probably some self-reflection that you can do on your driving habits around that, especially if it happens multiple times. See, that's why insurance goes up when you do stuff like that, because they're like, I don't really trust you anymore. But what if your brakes that you just got changed completely stop working, and that's what puts you in the ditch? I mean, there's no amount of retro now that's going to save that. It doesn't matter. It's outside of your domain. So if we bring that back to software and we explode it out into scope, listen, if AWS goes down, chances are people are going to have a lot of problems, right? But I'm not talking about AWS going down. I'm talking about bugs in your software. And if I'm going to talk about bugs, then we need to take a little bit of a tangent, digression, and actually define what a bug really is. So what's in the name when it comes to bugs? A bug is when something isn't working the way it was designed to work. And that's so important that I'm going to purposefully read it again. A bug is when something isn't working the way it was designed to work. So I'm going to look at a really simple case study to illustrate what I mean. Collectibles in video games. So in a video game, typically, I just played 2 back-to-back that are kind of similar in how they did this. You go around, you're walking around the world, you see this shiny thing, you're like, oh, that's kind of cool, let me go pick that up. So you pick it up, and in the game, in the bottom right corner, you have a little thing that says, hey, you just picked up this thing. Do you want to check it out? It's a collectible. And you're like, damn right, I want to check it out. So you press it. And it takes you to the in-game menu. And that in-game menu may have several categories or whatever, but one of those categories is probably collectibles. So you go over to that category, you scroll over to it, and you're like, okay, I want to check out this collectible. So you click it. And it's like, well, now it's in the list. You have a bunch of collectibles. And those collectibles could be in subcategories, but I didn't want to draw too much stuff. So you look at this sub-list here, and you have this little one that's highlighted. And you're like, oh, okay, let me go and check that out. You go there, and it has the preview on the right-hand side. But I don't know, I sit like, 10 feet away from my TV. I can't read the preview, it's too small. I'm not that old, but I'm old enough to not be able to read it. So I have to click on it, so that the preview turns into the full screen. And I'm like, okay, well now I can see the collectible. And I just picked it up. That was 4 interactions from the time that I picked it up to the time I could actually go and see the thing that I picked up. So what if we do a separate, what if the other game that I played? Same thing, walk around the world, see the shiny, click on it, little thing comes up contextually, hey, you picked up this thing, I click on it, and as soon as I do that, it goes immediately to that last view of the other one. So that's arguably 1 or 2 interactions depending on how you want to take a look at it, right? So the reason here that I'm talking about this is one is clearly better than the other, but the first one that I said isn't a bug. It's just bad. It's just a bad design. It was probably functioning the way that they intended. It's an afterthought. It was something they didn't really think through that much. So it didn't work. So I wanted to highlight this because I want to be very, very clear that if something isn't working as expected right now, it doesn't necessarily mean that it's a bug. Bad design is bad design. And a change in behavior is a feature, it's not a bug. Okay, back to where we were there. So why do we make bugs? Well, I mean, because we're all human and everybody makes mistakes. The distinction that I just made between the issue and the bug is just very important, so I want to drive it home. It's based on mistakes we make, not poor design decisions we make. So what happens when we make mistakes? Well, this is kind of the root of the hedonic motivation. The idea of wanting to avoid pain and tending towards pleasure in the everyday decisions that you make. So as an example, have you ever met someone that was defensive about breaking something or not getting something included in a sprint? Do you know anyone who doesn't want to take blame for something or tries to place it on others? What about someone that downplays consequences? Or have you ever heard the term, I'm sorry you feel that way, but, and insert thing. These are all ways to avoid pain internally. We're shielding ourselves from emotion by deploying these tactics. So in software, lending towards pleasure is actually usually building something new. Like a feature, everybody gets excited about building new things and building something they could put their name on it. I built this thing and look at it in the wild. So that call happens, right? And when I mentioned at midnight, you had that rough night, and then you say never again. You shake your fists, like old man grandpa here, and you shake your fist at the sky. And you do your postmortem, furiously type it the next day because you're so pissed maybe. Maybe you have a meeting, maybe you assign action items. But the company has to go on. There's hungry customers and they want more things. They want more features. And before you know it, that night you had, that shaking fist, that postmortem you did, it's not forgotten, but it's faded. And the hard work is difficult to justify because it slows down that new stuff that everybody loves so much. So everything fades quicker than you would actually might think that it would. As a good example, hey, how many of you have to-dos in your code right now that are older than 6 months or a year? How many to-dos do you have that if you were to read the to-do, you'd be like, I don't even know what this is talking about. I have no idea. Yeah. Of course you do. Everybody does. So that's kind of my point. But it works the other way too, right? A new feature is exciting when it happens, but it's quickly replaced with a chase to the next one. So here you have the situation where you have the good and the bad is actually forgotten in pursuit of the same thing. this newness that I'm talking about, this next thing to build. So now we have lower quality features. They may break more often, and they usually have a select few people that know the intricacies around them. So now we're on to problem number 2, box knowledge. People don't stay long enough, especially in smaller companies. In larger companies, the tenure tends to be a little bit longer, but in smaller companies, it's shorter. Learning under pressure is really hard. Sharing takes time to do that. You have to include that idea in your planning. And then there's the idea of comfort zones. I'll go through each of these separately. So normally, if I was doing this in person, I'd take a poll and I'd say, how many people that are here right now have been at their company at least 1 year? And you'd have like a lot of them. Even if I say less than 1 year, 2 a year, a lot of people put their hands up and say, yeah, I've been there. How about 2 years? Some hands are good. 3 years? Some hands would really go down. And I'd say, well, what about 3 years, but your company has less than 200 people? And then, I mean, you can't see it in person right now because there's nobody here, but you'd have very few hands left up because that's sort of what happens. Tenure tends to only be around larger companies. So when you have this idea of new people and impact, a reasonable frequency of new people coming in and out, especially in smaller companies, it's a blessing and a curse because while it can bring new ideas, you have to remember what we just talked about. New people want to make an impact quickly. They want to assimilate quickly. And so it's easy to understand why they would tend toward shipping features to increase their impact. It's a lot easier to put their stamp on something. I don't think developers are willfully ignoring quality to ship fast and get noticed. This isn't something that they're thinking through at night. But I think most of this is pretty passive, and it becomes additive over time. Think about your own teams. Do you have any like bus or lottery factor concerns for any part of your software? How long has it been like that? Why is it still like that? You're not actively trying to put more responsibility onto one person. Or what about that person that knows the microservice or specific part of the code so well that when a bug comes up, they can just fix it from somebody describing them? They can do it in 30 minutes. These are all forms of comfort zones or bubbles. And they're tough to combat when things are good. So let's look at it a different way. Let's imagine your team is a boat. Okay, and your boat is adapted to specific waters. So minor changes in the waters, like that picture to the right there, are okay. It goes left and right, and it may be a little up and maybe a little down. You know, nothing too crazy, right? But it's really difficult to plan. If this has been going on for a long time, it's actually really difficult to plan ahead when things are good, because you don't know things are possibly bad, or there's some sort of beginning of rot underneath. We're living through that right now. A lot of people had to make a lot of really fast adjustments when COVID happened, and nobody could have seen that coming and nobody could have planned for it. There are some people that would be more adapted to it because they may have some baseline strategies around something like this in the genre of it, but nothing to the extent that it's been, at least not for the vast majority of people. So when it comes to the boat, if you had a more adaptable boat, you can handle more challenging terrain. So I thought this boat was pretty cool. If you look on the right, it's basically a speedboat in its compact form and like a luxury sort of like cruising boat otherwise. And I'm not saying that boat is adapted to the specific waters that I have pictured next to it, but my point is that like it can handle more things because it's adaptable. So how adaptable is your team? How adaptable is your department? These are questions that I want you to kind of start thinking. So the root problem in this cases are all the same. Even well-meaning people don't really share enough context. And you need to share a lot for things to really stick. Most people need to read something more than once to retain even half of it. And if you read something when you're tired, you're even less likely to retain the things that you did read. And then when you're reading something online, it has an even lower rate of recall compared to hard copy. Do you recognize this? Because it's basically describing a large part of our jobs. Those code reviews you do, 2 p.m., after 2 1-hour-long meetings, when your kid's screaming in the background, yeah, you're not remembering anything from that. It's going to go in one, and most of it's going to go out. You'll have to review it again and again and again. So sharing and learning are very, very difficult things to do. So let me get into comfort zones. I have a friend of mine. He used to call himself the bubble boy because he liked staying in his domain of expertise. He would venture out of it, when his little tendrils needed to go and talk to other things or exposed to other services or whatever. But he generally liked to stay in his own domain. And he was the reigning expert of that domain. And he didn't wield that maliciously or with arrogance or anything like that. It's just comfort zones give you the permission to pass specific people problems in that domain and know and trust that it will get solved. And that's really comforting. But with that, there's a price. You get silos, you get that bust lottery factor is increased, and then it just amplifies the issue of shorter tenures at your company. Because you're left with pieces that others may not understand or even know about. And that segues into our next problem, conformity. So we're social creatures and we want to be accepted. That's sort of a really big thing, especially in a new position, in a new job, in a new company, in a new city, in a new country. So I'm going to go through some of these experiments to kind of prove what I mean. These are very famous examples, and you could find them in no time Googling them. So there's the Ash conformity experiment. And the concept is pretty simple. You as a candidate will go into this experiment, and you would be the only actual candidate in the experiment. But there might be, upwards of, let's say, 10 people in there, and they're all paid actors. And the answer, the question is simple. They present this diagram that I have up for you right here, and they say, what line on the right matches the same length of line on the left? And what happens is the paid actors, some of them answer correctly, but a non-trivial amount of them answer incorrectly and pick something else. In fact, they try to make it so the vast majority, as it goes around, if not all of them, as it goes around, there's variance, will pick a blatantly wrong answer. And you would think, well, who would go along with that? It's so obviously wrong. Look at the diagram. There's no way. But it turns out that in 12 critical trials around this, around 3/4 of the participants gave at least one wrong answer due to consensus among others in the room. 75% of people picked the wrong thing, and they knew it was wrong because everybody else picked it too, and they didn't want to seem like the odd one out. And I know you're thinking, not me, Chris. I'm better than that. I have a mind of my own. I've been like, yeah, they all said that too. Like, you can think that, but you have to be able to recognize these sort of human traits and be able to fight against them. So another more famous one, actually, is probably the Milgram experiment. It's a little more morbid, but this is the idea. I'll go over this diagram that's up here for you first. So the top left, E, that's the experimenter. T is the teacher, which is the candidate. That's who plays that person. And L is the learner, who is also a paid actor. L is hidden behind a wall of which you cannot see them, but you can still hear them. So what would happen is the teacher asks a question to the learner, and if they get it wrong, they send a small electric shock to the learner. And the experimenter is there to reinforce that action, to tell them, to shock them on the wrong answer. And every time they get a wrong answer, the experimenter, there's variance of it, so that either the experimenter or the teacher can increase the voltage. But the voltage must be increased after each wrong answer. And as the voltage increases, the reaction from the other side of the wall from the learner gets more and more dire for every time they get shocked. And this is a case study around how people follow authority. You can look at the specifics. I don't necessarily want to go into the exact specifics of it, but it was something in like the 30 or 40% of people would go to the point where the thing was marked like deadly voltage levels, and they would eventually go there if probed enough by the experimenter, because the experimenter's in a white lab coat and they have an authoritative figure to them. So they do this because the authority assures them that it needs to be done this way. And they continue way past what reasonable people would think when they're watching it from the outside in. So what does this tell us about code, though, right? Code is written by people, and people are divided and placed in groups and through some form of hierarchy, right? I'm focusing on these two specific examples on purpose because I think the first one, refers to team patterns, and the Milgram experiment refers to this concept of perceived authority. So let's start with the team patterns. Everyone here has probably been a part of a new team. And when you write your first new class or new test, what did you do? Did you write it from scratch? Of course not. You copy and pasted it. from some form of starter code, right? I actually asked 12 random colleagues that I work with, and they all told me that they copy-pasted code when they first started, and they actually continue to do so because it's faster in the end. Now, I know that's not like a perfect study and all that, but I'm sure if you ask people around you, they would sort of have similar stories. Because when we're unsure of something and not sure how to start, we copy it because it's already been a solved problem. It's already been vetted, it's already been approved. It's living in the code base. It must have been approved at some point to get merged. So we assume that if it's still around and used, it must have stood the test of scrutiny, and it's okay to propagate. Of course, from the previous thing that we just discussed, we know that there's issues with that assumption, and it might not really be the case. But what about questioning perceived authority? It's a little bit different, because instead of thinking that the code has stood the test of scrutiny, you believe that the person or people of authority have stood the test of scrutiny, and they must know what they're talking about. I found in my experience that this is easier to challenge for newcomers because there's sort of there's a less direct line from the person to the impact that a new person can have, to new output that they can do, as opposed to just copying code and just running with that. And sometimes that challenge can be of great benefit. I have a very close friend of mine who was trying to get pregnant for many years, and they were unable to, so they did one round of IVF, and that didn't work, so they went with a second round, and that almost didn't work, because they got to the point where they had to, the eggs didn't, they weren't fertilized the way that they needed to be for the process to continue forward, and they were basically told by the doctors, we're sorry that this one's not going to work. And my friend said, well, don't we have 2 frozen ones from the previous round that we could try? And the doctor was like, that's pretty low likelihood, I'm not sure if that's going to work. And he challenged the doctor on this. And the doctor is, he's the expert in the field, knows the statistical relevance, knows how that's going to, whether it's going to work or not based on hormone levels in the wife and all that. They're the expert, right? But he challenged the doctor on it. They ended up doing it, and now they have a happy, healthy 3-month or 2-month-old, right? So sometimes to great benefit, if you challenge the authority and you have the courage or the previous experience to do so, you can overcome this problem. But the problem with it is that you're still counting on somebody breaking the cycle versus being pragmatic against the cycle. So you still risk that nothing ends up changing. And I don't think it's necessarily worth that risk. Okay, so in practice, what does this actually look like? What are the signals of this, right? So very few people want to speak up to issues that they see in the beginning. They want to be accepted, as I mentioned. And new engineers copy code and patterns that they see to other places. So if undesired code already exists, this is a great way to spread it, almost like a disease through your whole code base, depending on how fast you hire, all that stuff. There's nuance, obviously, around all of this. I'm kind of simplifying it for the purposes of this talk. Okay, so let's bring it all together then. So you have the hedonic principle, saying you can write bad code, and that feeling of badness gets forgotten or faded away because you want to deal out new features at a reasonable frequency. You have the hedonic motivator. Coupled with that, we talked about that it reinforces it, and it can also reinforce the behavior of avoiding conflict if some code might be found to be less than stellar. Especially in newer companies, people might not actually stay that long. Institutional knowledge tends to stay in people's heads. And when they leave, might be hurriedly transferred, documented to a lesser degree than maybe if it was systematically shared. It might be a little bit different. It might be spread a little bit more organized. It might be a little more filled out. So a lot of that stays sort of behind this code that no one might actually understand fully or understand the origin of. And when bugs happen, the first thing that every developer turns into an archaeologist when a bug happens and they're trying to figure out what went wrong. Because the question around bug solving isn't how do we fix it, it's why did it happen? Because you need to understand the root cause. If you don't have enough documentation, institutional knowledge around that section of your code, that's going to be much more difficult to do. And it could take quite a bit longer to fix the root problem. So now you find people that are prone to conform. That's the last point here. Now you find people that are prone to conform under even fairly slight pressure to do so. So all that odd code that could lead to questions, not only do they keep it to themselves that they think it's weird and might not ask the questions that they should, but then they go one step further and they copy paste it around the code base, spreading it and making it appear in more and more places. So all these aren't siloed issues, right? They all kind of they're all woven together, and some can be more present than others depending on where they are in the company, what the company is doing, where the values are, and what the culture around the engineering teams do. All right, now that you know the problems, you know that they all intermingle together, you know that some of them are worse than others. There's a lot of variability, a lot of changes between one company to the other, one team to the other. So how can we make this better? I think there's some certain strategies you can employ that are pretty universal. So for the treadmill and motivator, we can change how you look at your tasks and stories. And you can try and build trust into your team. And as a more practical effect, you can try and create a quality guild. So let's start with the first one. The reason new things are cooler than refactoring and documenting, refactoring or documentation or purposeful context sharing is because we make it that way. We see this hierarchy all the time, and quality is usually a secondary concept because it's behind the curtain of product. Salespeople sell salespeople sell things that the product doesn't do and sometimes can't do for a really long time. There's a bit of a disconnect there, but they want to make that sale. They want that new customer. Product sets the roadmap with little input from engineering. And really the only negotiation that engineering might have is we can't build that in the amount of time that you told us. When really the negotiation should be on scope and timeline, not just timeline itself. So when refactoring is considered, it's usually bolted on, and it's not a natural part of the work cycle. The Boy Scout rule is nice on paper, this idea of every time you go into a file, you make it better before you leave. I've heard that a lot, but in practice, I've seen it happen a lot less than it should. So actually, to give an example, a company that I used to work for had something called a refactor-geddon every year. So at the end of the year, the engineering would stop feature work for five or 6 weeks, and they would just focus on addressing whatever tech debt they wanted. We had a big kickoff meeting, teams were formed, we discussed priorities of what to address first, broke off into squads, and managed all of our own work. Product didn't have any say in any of this. And I couldn't help but think that feels a lot like an us versus them mentality. So we can try and advocate for durability as much as we advocate for features. That should be half the job of a tech lead. Build the cases for engineering quality and argue it the way product argues for new things. They should be at the table for these conversations for road mapping, and that should be what your tech lead does. You can have a better senior developer than you do in terms of craft than you do of a tech lead because the jobs are so different. I'm going to say it again. Your technically lower level senior engineer can be a better crafter than your tech lead because the jobs are completely different. Okay. So in order to do this, though, even if you want to advocate, you have to build trust. And trust is very hard. So this diagram that I have here is actually from a book called The 5 Dysfunctions of a Team. And the first dysfunction listed in that book is the absence of trust. I highly recommend reading this book for more context on this. It's excellent and it's told as a story, so it's very engaging. So their definition is a little bit different than when I say trust. I mean more like openness to communicate honestly, as opposed to the lack of politics, which is what that book tends to focus on. But at its core, it's the same sort of idea. My concept of trust is the first two parts of that triangle: fear of conflict and absence of trust. People should feel comfortable speaking up when things are being debated and negotiating without the fear of negative consequences around that. So remember how I said tech leads should advocate? Imagine if there were part of roadmap discussions, customer interviews, metrics analysis to gain as much context around the problem domain, and then bring in the unique perspective of maintaining high engineering quality. They should be in all these conversations, and they should have an equal seat at the table. It's easy to understand that a more focused eye on quality decreases incidents, but this will still bring up conflict because it slows down product delivery compared to what the team might be used to. That conflict that leads to compromise is the part that relies on trust for the team to succeed. If you cannot have the conflict and people either hide their feelings or they just sort of agree to things because they don't want to deal with all that. That's the part where end quality goes to die. And the only way to fix the plug is to remind the captain that the ship is leaking. Trust must be built into your culture. It can't be bolted on when it's convenient. It's on a one-day fix with a seminar because old habits die hard. It takes real dedication, real work, and candor is the hardest part of that. So this topic on trust alone can be its own conference talk. So that's why I recommend reading 5 Dysfunctions of a Team. It's by Patrick Lencioni to learn about propelling the team to high performance. It's about 200 pages, 230 pages. You can read that 2 days. It's very, very engaging. Highly recommend. I don't know if I'm making it obvious. I highly recommend you read this book. Great. So what about making a guild as a more practical concept? So a guild is just a collection of people that are responsible for keeping an eye on quality. It's not their only job. It could be people from product, people from eng. It's a highly sort of flexible structure. Anybody who want in, but part of their time is dedicated to sort of making sure this keeps top of mind. Because everybody wants quality on paper, but this idea puts a team to the task. You can have people cycle on and off the guild every few months so that it propagates out a little bit. They should have their own metrics. They should meet on some reasonable cadence. I think the last guild that I was part of met every 6 weeks to discuss parts. We had action items that people were responsible for getting other people to work on. The members of the guild don't necessarily fix these quality issues, but they are assigned to making sure that there's movement made on them. So you can get a little creative with guild. You can make maybe the guild is a path to promotion. Maybe if you want to be able to go from a senior to tech lead, maybe you have to do some time on a guild to understand what that means. Maybe when people are on a guild, you can pay a guild stipend. Like there's different avenues you can do to make it more enticing to people, but the focus of this guild is to have accountability and keeping these issues top of mind. So, what about some box knowledge idea? Okay, well, knowledge sharing should be just a general goal, right? I mean, if you want to solve the problem of people not knowing things in the code base, then you should make it a priority to share it. And while that sounds so simple on paper, it takes time. And so because it takes time, you should endeavor to add these concepts to your sprint, to your 6-week planning goal, to your monthly planning goal, because lunch and learns, pairing sessions to share this knowledge, all these things take time and effort. So if they're not part of the sprint, they're shoved to the side, they're swept under the rug, and they're never done. So you can do pairing code reviews even. Go through your code review, and then if you're doing a pairing session for actual code to write up a new feature or fix a bug or whatever, delete that code and then turn it around and have the other person do it. Because you want to make sure that the understanding of it is what is cemented. There's too many coding sessions where somebody is driving too much and the other person is an observer, and then when they're done, they might have a general 10 to 15% retainment of what they had, but if they're forced to do the thing they just looked at, they'll retain way more, but it takes twice as long. By doing this though, increasing the amount that you share, making part of your sprint, doing it in pairing sessions, doing code review in pairing sessions, it slowly starts becoming part of your engineering culture. That's the end goal. You need it to be part of something where if it doesn't happen, you want people in your org to call it out. Back to the trust thing. But that's kind of what you need. You need it to be part of the culture. So as a barometer check, can you point to something every week where you actively spread knowledge as an employee yourself? Can you say, I taught this thing to that person. I wrote this documentation for that thing. It's a barometer. It doesn't have to happen every week. But it's like an idea of like, how can you make it more accountable? How can you keep track that it's actually happening? And thirdly, the conformity angle. Because you have people that want to fit in, not question authority, there's a couple things that you can do around this. You can delay the authoritative voices in the room when something comes up. You can have your more junior people talk first, or maybe you can have people write things down and then go around the room and have them share what they wrote down around a problem. When you're solutionizing an issue, when you're spitballing ideas around how to architect something new, if you have your most authoritative people talk first, A, they'll talk with authority, and B, so your more junior people will just think like, oh, that's the way to do it. But you might actually get some really interesting ideas and different perspectives if you let the more junior people talk first. You have to find something that works for you. These are two basic ideas. And there's another conference talk around this entire issue of conformity done by Sandy Metz, Keep Ruby Weird keynote of 2015. And I highly recommend it. I'm not going to lie. I stole this concept pretty much directly from her conference talk. It's excellent. Much what you would expect from Sandy Metz. So think about those two concepts of like how you might be able to decrease the authoritative voice in the room and just give space to your more junior people to have an opinion. They might not have the right opinion or the best approach, and that's where your mentorship can come in. Speaking of mentorships, you should assign mentors, and you should assign them with accountability. Because if you don't assign them with accountability, or you don't have mentors at all, you have something called the tragedy of commons that happens. Because people tend to want to fulfill their own goals first. So if everyone is responsible for the greater good, then really no one is responsible for it. And think back to if you use Slack or HipChat or whatever other messaging you do in your company now, especially now with remote. Think about a question asked to a channel versus a question asked to a specific person. Usually in a channel you might get vague responses, more minimal follow-up. You might not actually have something like seen through all the way. But if you provide a single point of contact, then you tend to break down a lot of those barriers. People become more open. The new hires, they might at first be hesitant to message that one person, but eventually that rapport starts to happen, and they'll message them with more detailed explanations more often. They'll get better explanations from their mentor, and the problems will be addressed more fully than if they were in the channel. I think the channel is good for general questions that are around a piece of software that you're writing to kind of hash out ideas with the team, but more specific, especially onboarding questions around like the early time. I can't get my dev environment to start up. I don't know who do I talk to about this part of the code. Those kinds of questions they're more shy questions, and especially for newer people, going to a specific person, I think is highly beneficial. Now there is one important caveat is you can't just assign any mentor. They have to want to do this. If you have people that you assign as mentors and they're not interested in doing this, they will not make good mentors because they'll just pawn off the questions somewhere else and they won't really dedicate the time that they need. Mentorship is a good skill to have as a developer in general. I think we can all agree with that. So hopefully you have more people that are interested and not, or they go through cycles when they're maybe more busy and they can't do it, or they're less busy so they can. But I think it's highly, highly valuable across the org, across the engineering org at any level. I think it's really good to do. Great, so I've added a few things that you could do to fix this thing, right? But I want everybody to remember that all this is human nature. Like nobody's doing any of these things on purpose, right? They're not doing it maliciously. It slowly snowballs. But I'm hoping I gave you some ideas of how you might be able to proactively spot it and maybe even combat it. You're going to make the effort somewhere, right? You can either do it a little bit at a time, or you can do some massive 3-year rewrite on a huge part of your code. I'm hoping that maybe I convinced you that one might be better than the other. And it all kind of comes down back to this diagram, right? You have your environment and your mindset and your behaviors that are working together. You can imagine now that if I've changed your mindset about some of this stuff, it might influence some behaviors that you take out from this that will slowly change the environment. So you'll have to adapt these ideas as you go to really kind of get where you want, and it won't probably ever be perfect. Things always change, but I'm hoping that this cycle loop, the problems I've identified, and some of the strategies that I've talked about can really help you kind of get through this. So hopefully nothing's too rotted, but I hope you enjoyed this talk. I hope I'll be around, obviously, to answer questions, Slack and YouTube. I'm not sure how that's going to work quite yet, but I'm around, happy to chat about this more. Thank you very much for listening to my talk.
Hello, friends. We are live now. Thank you all for joining. And feel free to introduce yourself.
Oh, hi. I'm Katie. I work at Circle CI as the technical community manager.
And my name is Dave Stokes. I'm a community manager for MySQL products at Oracle.
Hi guys, my name is Bhavin Patel. I'm a solution architect at OutSystem.
Hi everyone, I'm Ted Pennings. I'm a product engineer, a front-end engineer at Lightstep.
Hello, I'm Cliff Jenkins. I'm a part-time instructor with We Can Code It and a senior developer at Alliance Data Systems.
Hi, I'm Brandon Rockwell. I'm one of the coordinators of the conference. I help with logistics and operations and those kind of things.
Okay, so we will get rolling. So it's an open question to all, right? So today we have various changes, the tech landscape is keeping on changing, and developers, they always have to learn X, and by the time they learn X, you get Y, and by the time you learn Y, there is another Z. So my question today to all of you is what is your suggestion for developers to stay relevant in tech today?
Give up all hope, ye who enter here. When I started programming back in the last century, you needed to know a text editor. You needed to know your compiler and maybe a linker. And you learned how to put in trace points for when your code went bad to kind of dump out variable points. I look now at the young developers coming up, and not only do they have to know their language of choice, JavaScript, some sort of front-end framework, some sort of back-end framework, some sort of database, some CI stuff, some debugging frameworks, how to do stuff off GitHub, how to put it all in the cloud, how to all coordinate it, and how to get it all off of cell phone. The learning curve has definitely spiked the past several years. So it's one of those things where there's no way you can keep track of every new thing that's going on. So best you can do is pick 2 or 3 things that you think you might be able to put your fingers around and hold on to, and just enjoy the ride.
That's really funny that you say that, David, because for lack of a better, I came to code later in life. So I am still a relatively new developer, 4 or 5 years. And I think that I totally agree. It's very overwhelming landscape. My approach, I guess, or that engineers recommended to me when I started was that I really tried to focus on the foundations. If I'm going to learn, let's just say React, I'm going to learn a tool, but is there the underlying sort of philosophy of why I'm organizing things in this manner? I found that to be more easier to take with me to other technology. So I would say that if you're really learning a tool, also learn the sort of philosophy that goes along with that tool, because you may have more opportunity to sort of take that with you than the actual tool itself.
Yeah, I definitely agree with that. Advice that I give to early on engineers is to find something you're interested in kind of early on, and then stick with it for a while and get a lot of depth there. And that process of getting a lot of depth teaches you a lot about how to learn things in depth. And then once you've done that, you not only know something really well, but you know how to learn something really well. So you can apply that to other things.
Go ahead.
Sorry, go ahead, Dave.
I was going to say something else you can do is when you're at a conference like this one, look at the schedule and find something you know absolutely nothing about that isn't something that's going to be a hot trending topic for the next 6 weeks and then disappear. And even if you don't know anything about it, it's a complete tangent away from what you're doing. Invest an hour of your time, 30 minutes of your time, and go in and sit in that session and learn something different.
So I'll take this a little different direction, though, a little philosophical, right? Because a lot of people call me jack of all trade, master of none. So I'll put that myself in that category, right? But just to make sure that we stay relevant in the ever-changing environment itself, I would say start with embracing the change. Don't fear the change, right? Because the change is going to come regardless. if you just look at the front-end technologies, right, man, there is some variation of it. It comes out almost every other month, right? And particularly out of West, there's new framework which has been wildly successful for one company, and they became open source, and now there's a gold rush to learn that because that's going to solve world's problem. That's not necessarily the case, right? So if you really understand one technology, the learning the next one is going to be easy, right? So I would say just don't fear that, instead embrace that. And the second one is, I would say, is focus on your talent rather than actual skill, right? So soft skill in terms of how you learn things, because everybody learns things differently. What are you good at, right? So I personally think, and a lot of people disagree as well, I have a very analytical skill in terms of understanding the problem. I think that's my skill and has worked so well so far, right? Knock on wood. But just focus on that skill as well, or talent, I should say, as well. And learning the technology is gonna, that's an evolving process. That's not gonna end, right? That's always gonna come with you, right? Because you are in that field, it's gonna change. But let's keep our mind sharp in terms of what we possess, and that will kind of guide you through the taking the next skill set, right?
I'm curious, Cliff, you said you're a part-time instructor, right? Do you feel like you have to teach people about this sort of question?
I do, definitely, and I've been asked that question many a time. And I think one of the biggest things that the question that comes about is like, how do we learn so many different technologies? And one of the things that I tell the students is that don't fear. Learn, as been mentioned, learn one core technology. Know the basics of that technology, because when you learn other technologies, it becomes easier. But I also have to remind them that you cannot, and the key word here is become complacent. You cannot become complacent with the technology that you're learning right now. You must be willing to break your fear of getting outside of the technology that you know, and to go out and to learn other things. For instance, I attended the conference here last year. I'm not a JavaScript developer by no means, but I went outside my comfort zone to learn more things about JavaScript, because I don't want to become complacent. JavaScript is becoming the beast that it is, and you don't want to be left behind when it eventually does overtake some of the other mainstream programming languages that exist out there. So as far as students are concerned, I definitely let them know, hey, don't become complacent. Find your comfort zone, as Ted said, find your comfort zone and stick with it. I'm a jack of all trades, master of nothing either. But the biggest thing that I know that I do on a lot of occasions is I dabble with a lot of different technologies, and I found that some technologies just don't meet my, don't have a taste for it or palate for it. But at least I dabbled with it, just so that if I have a conversation with you, Katie or David or whomever, if there might be a technology that you are strong with, at least I can have a intelligent conversation with you about it and learn some things as well.
Part of the way of learning is learning how to break stuff and then fix it so it works again. So never be afraid to break stuff. Second thing is learn how to read documentation, and better yet, learn how to write documentation. It's often, I get hundreds of people each year coming to me, how do I learn SQL? How do I learn to run in a database? How do I learn to do something like that? And it's not that they don't have the mental capabilities, they just haven't learned how to read the documentation and go out and experiment. And like I said before, you learn a lot, especially as a junior developer, by breaking stuff that someone else has developed and then fixing it so that you actually can get it running again. So don't be afraid to break stuff.
I'll add one thing onto what David said. Before you break something in production, like try a rollback once and know how long it takes, because that can be stressful. But if you know how long it takes and you know how to do it, it can be like not a big deal.
Two common general goals you'll hear most developers tell you: make backups, and lots of them, and learn how to use the source control system. And no matter what you do, you're going to find yourself late at night one night because the source control system failed you and the backups failed you, and you're trying to remember what you wrote 4 hours before.
One tip on that. Git has the ref log. So there's the regular log and there's the ref log. And the ref log lists like every single commit ever. If you have a bad rebase, go look in the ref log.
Excellent point. So kind of to follow along that line of thinking, the next question is, I'll ask Cliff first, and then everybody else can chime in. So as a new developer, what advice would you give if they come to you and they say, yeah, like I understand, I want to learn, or I need to be able to step out of my comfort zone, but I really want to have a plan for what job to look for to start off, or just what's the next thing. Do you have any specific advice for somebody who asked that kind of question, like about having a plan, or should they just not even have a plan and just focus on finding the next thing and adopting it?
Brendan, definitely you need to have a plan, because those who fail to plan, if you don't plan, you fail to plan, you plan to fail, as the saying goes. Definitely have a plan. Those that are looking for a specific role, say they may approach me and I may not know, specifically a front-end developer. Hey, we may have, as developers, we definitely have a network. We need to put individuals, new developers, junior developers, we need to put them in front of individuals that we know that can advise them on the plan that they have taken to get where they needed to go, whether it's just technical or just career-wise. We need to put them in front of, and that's the start of a plan there, so that they can speak with those individuals to understand and know, hey, is this the technology that I want to be involved with? Yes, we're definitely getting into a time period right now where everybody, it seems like all employers want to have some type of full stack developer. But unfortunately, not all of us are front end and not all of us are back end developers, and very few of us know how to intermix and do both of them. So I advise and instruct that, hey, find that mentor, find an individual that you can speak with, that can lay out how they got there, and evaluate what it is that you would like to do, what you want to do, and move forward from that standpoint.
Go to your local user group meetings and ask questions of folks where they're working. What are you doing? How'd you get there? What are you looking for? Gee, how do I learn that? By the way, if anyone's been in the business for more than 10 years and they're still programming in the original language they started in, there's something wrong.
Sometimes I tell people to find more than one mentor so that they have mentors for different areas. Maybe one that's like career growth and one that's like technical matter, only because sometimes it can be hard to find somebody with all of that in one, or who has the time to do it all. And then also you get to see more different types of engineers. I was very lucky that I knew a lot of engineers when I was learning to code. So I had the ability to kind of get a feel for what they did. I knew a lot of Ruby and Rails developers at the time. And then I started learning more about front end. Then I got a job at a database company, so I learned about that instead. But they were all really helpful foundations. So I think that like some really good advice is to talk to as many different job titles as you can, because they're different, like all over the place.
I agree with Katie. That's also network with different roles, right? It doesn't have to be software engineer or architect, or even go outside in terms of look at the different role in terms of how you become a product manager, for example, right? Because the perspective will change from role to role. and you are better equipped to make a better decision when you look at those different perspectives.
Yeah, and it'll make you better at your role too. Like if you spend some time with your product managers or like the salespeople and like customer success people, you'll like learn how people use the product and what's like broken, and you'll find little things. Like in a past job, I found that there were some places where like we weren't using color to indicate that like things were like bad. So like I had some red and people thought it was better. And it was like a simple change.
Awesome. So next question, Ted, what would you suggest to developers and how they can stay relevant and maybe even stand out in today's world with this constantly changing front end landscape specifically?
Yeah, going back to the last question, I think it's important to like have this like network of people to give you like advice on technical and like professional growth, like soft skills and stuff. But it's also important to like assess the strengths of your peers, so you know like where to go when you have like a certain kind of problem, and when you want to learn something, you also know where to go. It can also help to let you focus. Like I'm really lucky that over the last like 4 years, I've worked with like different people who are great at Webpack, and I still know nothing about Webpack, and I'm like thankful for that. If I have to learn something about Webpack, like I definitely will, but I'm so thankful that like other people specialized in that I've worked with. The last thing I'll say on that is like read a lot of code. Like writing code's important, but reading code I think is even more important. So like read the code that your colleagues are writing, like PRs and stuff. Like go through and take a look. Read change logs for the libraries you care about. If you see anything interesting in the change log, go look into it. Maybe even go look at the code to see how they did that.
A friend of mine has a code review with his developers, and he tells them each to bring one piece of code that they wrote that they like, piece of code they wrote that they don't like, and something they found in their repository that just confuses the heck out of them. And sometimes it's a 15-minute meeting, you know, oh, that's some good code, that's some bad code, all that. Other times it leads them down to a theoretical discussion. Well, why do we do it this way? Why is our code legacy written this way? Why do we have this technical debt? Why is it this way? And the good thing about database, well, the good thing about most code developers is after about 6 months, you can look at a piece of code and tell if it's a piece of crap. In the database world, you can't look at a query and tell if it's good or bad or indifferent until you actually dig deeper. So in some respects, you not only have to know what the code does, but what's the layer beyond. A lot of times I see people setting up databases and they have not normalized their data, and you start asking, well, how are you going to use your data? Well, I want this ID to return this, well, that's not the way you laid out your data. So go out and look at some of the traditional stuff like relational technology, how to normalize data. Other thing is, once again, documentation, learn to write good documentation, have other people look at it. And the folks who get further in the world are the ones who write code and documentation so that someone else can understand what they're doing. Because that way your boss looks at you and goes, okay, their stuff is solid. I can actually move someone in there and they'll be able to comprehend what's going on. This person, if they're tackling new stuff all the time, I can move them on to some other new project.
Cool. So let's move on further. And now my question is to Katie. So Katie, so where do you see like CI/CD in next 3 years? Because CI/CD has got a drastic change in the last for let's say 5 years. So what do you see for the next 3 years?
This is like interesting because I was actually just having like a discussion with a lot of the engineers at Circle yesterday about this, because they're sort of right now, I feel like people are trying to decide if they want an all-in-one platform or a like vendor agnostic modular piece that works like anywhere. And I honestly think that like that's the decision that's going to be made in the next 3 years, although maybe it will take us 3 years to make it. I tend to think that it will go towards vendor agnostic, because I write my code in like a modular fashion, right? I like break it down to the smallest possible pieces because I know that if I write one super long main.js, which I've definitely never done, then like when something breaks in there, my life will be difficult. And I kind of think the same principle will apply to CI/CD tools. If I put everything in one platform and then that platform is unavailable in any way, then I have like this massive single point of failure. So I kind of think that we're going to edge towards saying like, what's the smallest possible change I can make? And then what is like, how often can I make it? Which I think is like a pretty common, right, engineering philosophy. And they apply across the board, right? So like the idea of continuous integration is that you make small changes, you make sure it works. Make small changes, make sure it works. And I think that like the idea of adding in this like more massive platform doesn't always sort of jive with that idea. So I think that's a little bit where we're headed, but also we're really in the next 3 years going to be realizing, I think like our current times are telling us how important CI/CD is, right? This idea of like reliability in the time of a pandemic is incredibly important, as I'm sure Ted works with observability. I'm sure he knows too. It's this idea that like you need to make sure things work, especially like the more important it is for your users, right? So if like you have healthcare, then like you're gonna need like you don't just want to like think about continuous integration, you want to implement it because it matters. And I think, you know, all of our software, regardless of whether it's like life-saving, matters to us and it matters to the business, of course. So I think that like we're gonna see that adoption, just like a philosophical, like this is a requirement. And then also we're gonna start deciding where the tools themselves fit in our larger architecture.
I think we're also going to see more robustness in like that whole pipeline. Like a lot of the things that have happened with CI/CD over the last like few years are like head and shoulders better than what we had before. But the tools that fit into that are also that way. Like I'm thinking about like Cypress, for example, like the way that like Cypress runs inside of like a CI/CD pipeline is like really incredible, and it can do so much for you. And we didn't have that a while ago. So the whole like testing ecosystem is like moving upward beyond just like the core vendors you think of like Circle CI. And I also think that we'll have like a move towards more abstraction there. We've kind of already had that with like cloud things with Terraform. So I don't think it's unreasonable to expect it's like the equivalent of that with CI/CD.
Right. Any other thoughts from the panel on this? Okay, so we'll go ahead. So now let's go to database, right? Dave, I think when I say database, I think I see a smile on your face. So in database today, there are many databases, technologies you keep seeing day to day. Like we started with relational and then we ended with NoSQL, and today you have various serverless platforms coming in, right? So what do you see for next 5 years or 3 years?
Well, relational technology is going to be around forever. It's the basis of all business logic. So if you get a chance to study data normalization, relational theory, set theory, and all that, you'll even hear relational calculus. Don't be worried by the words. They're just ways to organize your data. It's going to be around forever. Now, about 10 years ago, when the NoSQL databases reappeared, by the way, before they had relational databases, they had NoSQL databases. They just didn't call them NoSQL databases.
VSAM.
The NoSQL world introduced the idea, well, I don't really need to do all that structure. I don't need to set up relations. I don't need to do that. And it's a lot faster for me if I'm not tied down by all this tradition. Well, that's true. And the funny thing is all the major relational databases have added NoSQL functionality. For instance, MySQL can act as either a relational database or a NoSQL JSON document store. And you can get the data from one side to the other side. It's all the same platform, all written on the same data type. Makes it easy peasy for you to do that. Meanwhile, some of the non-relational databases, NoSQL databases, have been trying to add transactions, which they're finding very, very difficult even after several years of effort. So go out and learn how databases work. Once again, big secret with databases is make backups and then make more backups. What you're going to see in the next 5 years that I think you're going to see is everyone's running to the cloud. Unless you have some sort of HIPAA requirement or some other government requirement where you have to keep your stuff on premise. The cloud makes everything so cheap. The original birth of relational databases was because they had very expensive disk drives and they did not want to duplicate data. It was the original deduplication effort. Well, now that disks are cheap and memory is fairly cheap and now processes are cheap and the networking is cheap, you're going to see more and more data stored out there in a variety of formats. So you're going to see more of everything, and it's just going to, the tumult's going to increase. Now, the vendors are trying to help you out with some tuning tools on the back end where they do some machine learning. Gee, at this amount of load and this amount of queries, this is what your data looks like. But now the data load is going up higher and there's more transactions going on. So how do we tune the back end for you? You're going to see a lot more automation that way. On the user end, it's just going to, for you folks out there writing front end stuff, trying to write the back end stuff, it's just going to get more messy or messier. So hold on to your hats, document what you're doing, and write good code.
As far as database technologies is concerned, I'm going to kind of co-sign what David just said there. It's not going anywhere. And if you look at it in the realm of computing sciences, developers, we don't exist without some form of data whatsoever. And databases within itself, its area can get, kind of messy and get kind of complex, but very intriguing as well. We are going to continually have to deal with understanding how to utilize and leverage data. Hey, some of the biggest companies on earth right now exist simply because of data. Well, we look at Google. If anybody started utilizing them 20 years ago, when they were first coming out, it was kind of interesting how they were able to just pull up all the data that they were and then look at the beast that they are now. We are all familiar with the beast that is Amazon, which many of us probably wouldn't have survived without its deliveries throughout this pandemic. But these companies exist because of data, and the data that they get to realize, and even other organizations as well, they lean and depend on data for creating up different types of different business models and how to leverage the businesses that they have, and basically how to generate more revenue. Data is always going to exist out there, whether it be in the form of NoSQL, relational databases. We just have to come to a understanding and recognizing that, hey, we exist. It's coding and data is like first cousins. We code to get the data, and data needs to be utilized because of the coding that we utilize. So in the future, hey, it's going to become more intriguing and interesting. I mean, the biggest thing out there, the fresh face out there is what GraphQL. That is a big player out there, very interesting. I've dabbled with it, being that jack of all trade. Very interesting, but we'll see what comes after GraphQL. But we have to come to a realization that database technology is something that has a huge future ahead of it.
I would just add too that there's some emergence of like specialty databases too. So for example, when I say I worked at a database company, I worked at a time series database company, which is like its own special little corner of the world. So I think too, I don't think you need to learn them all, but I do think that like, as you're getting like further along in your career, it's really good to be aware that like, there are more types of databases than probably any of us care to know about. maybe except for me, because I do really like them, I do. But yeah, just being aware that there are like lots of specialty databases out there, and like I agree that they exist for a reason. And it's really interesting to learn about the reasons that they exist and the problems that maybe like come up in traditional databases that like spur the birth of like something so niche. So it's a good thing to just be aware of and keep your eye on.
Yeah, I definitely agree with Katie on that. I work at a company where like we're very invested in data, like observability and making sure things are running and all that. We have like around 6 different kinds of data stores. Like we have like a regular MySQL like thing, and then we have a bunch of different databases that we've built to handle the kind of data that we have. And the thing that has like helped with that is that we spend a lot of time on our interfaces between like the different services and the front end and the back end, and that makes it easier to like swap out the underlying persistence. So I would say that like just as important as being thoughtful about like the database choice and the database design is being thoughtful about the APIs, especially if you have public APIs, because those are extremely hard to change. So putting thought into that can give you more flexibility to respond to changes, whether it's like maybe outgrowing like your database or outgrowing what you want to pay for your database.
Cool. So that's a great information on database. Like everyone understands that without data, excuse me, without database, there is no web, right? So we need data and we need web technologies which support database. And Cliff, you used a good terminology like web and data are like cousins, right? So they go together. Cool. So my question now to Bhavin. So Bhavin, what do you think about low code space, and do you think the traditional developers are going to be impacted because of low code, or do you think it as an opportunity for developers to embrace the change and use low code technologies to develop solutions faster and deliver solutions faster? What is your take on that?
So obviously I'll be biased, right?
Right.
But at the same time, when I was looking into low code, and again, low code is not a new technology, right? And now it's in the forefront. But if you look at it from Access to Lotus Notes to SharePoint, all that has some sort of low code concept, right? And the philosophy behind it is from the beginning is we have looked at productivity for every single industry, every single job. Just look at all across, right, man? From manufacturing to back office, everywhere we look, there was a big word, productivity gain since 2000, right? For next 10 years, we focus so much on our productivity, which is actually a good thing, right? When we produce double the cars today with same amount of labor force, actually, right? So that's a productivity gain gets you. One thing we never looked at is the productivity for developers, right? It's not replacing a developer. It's more of a how can we complement a developer to make things faster, right? And again, demand is not slowing down. So if it slows down, certainly the value of the technology goes down, right? Because if, let's say, tomorrow you need 500 million applications, which Microsoft says they'll need, when world will have 500 million new applications in the next 5 years, right? Gartner is kind of predicting this in the same line. If the productivity, if the demand goes down, which all of us know that's not going to happen, right? Then how can we make that process faster to take your solution to the market faster? And if you look at the technology trend itself, right? If it takes about 18 months to 24 months to take your solution or your product to market, you are already legacy, right? 18 months is eternity in technology today, right? It is eternity, right? 18 months later, you have no idea what's gonna be, right? I mean, just take an example of Uber, right? Uber was this groundbreaking technology, if you will. It's concept rather than technology, right? But because of their nimbleness and to deliver things faster, think of that how fast they can get the market share, right? When I remember back in February, Uber Eats valuation was very low, and then all the DoorDash and everybody else. But because Uber can integrate that faster into their app, because that's what they are providing at the end of the day. And if they are the first mover, you can capture a lot of market share, right? So that's the value there, right? And in terms of developer hesitation, yes, I completely understand that as an engineer, we are one of those species who are always a little hesitant about change, right? But I guess my analogy to that change is my parents' generation was working in maybe not necessarily my parents, but myself worked in COBOL, right? My parents' generation worked in assembly language, right? And then there was a flood of high-level language called C and Java, a number of different variation of it. Now we have more of a client-side technology in JavaScript and all that, right? So that change is gonna happen, right? But if you look at low code in general, it's one abstraction of that high level language, right? So what you are doing is you are still using your analytical engineering mind to build out a product which solves real world problem, but at the same time let machine do the rest of the work, which is just converting that into, let's say, high level language, and then at the end of the day it's assembly level language, right? So it's just one abstraction of it, just next evolution, if you will, right? So I see it as a complementary to anybody's skill set, right? Because if I say I have built so many projects in my resume, sure, it looks good, but very high level, if you look at from management or product manager perspective, if I say I deliver this project in 2 months, that's even better, right?
Right.
I kind of like to when you mention low code, you know, if you talk to anyone from management, they always want to throw in low code, no code, and we always know that the no code aspect of it is a fallacy. It's always going to be some level of code associated with it. From those of us who are developers, I personally, I'm neutral to the low code. I've dealt with working at Alliance. I haven't deal with Salesforce and other applications like that. See it less as a threat and more of an opportunity, because it definitely can help out the business to get things out quicker and faster out the market. However, every organization is different, and there's going to be some level of customization that needs to be done. And then that's where the developer comes into play with helping out that aspect of what needed to be done from a business standpoint to get to market faster. But in order for the organization to really leverage it, the developer comes in to utilize the specialization programming language, Apex, or what it may be, if it's Appian, Sail, in order to tweak things so that the actual aspect of revenue is generated. So going forward, developers shouldn't fear the low code that exists out there. We should embrace it. We should look at other opportunities out there to to learn from it and see what we can do from a customization or low level standpoint in order to improve it, and just literally build up our skill set.
Now, being the probably the oldest person on the panel, I can tell you that when I started programming, everything had to be customized. There was not a lot of packages you could buy, install, and run. Usually you're buying from your hardware vendor. And then the idea of prepackaged software started coming up, Peachtree accounting, all these other things. The only trouble is companies had those packages, but they didn't like them. They didn't fit what they needed to have done. So they started hiring programmers to come through and customize them. Once you do that, you're kind of locked into that version, that release, and very, very expensive to have vendor lock-in. That's why open source software really exploded, because the hardware vendors and their software prices were escalating every year, and you were locked in, you were stuck, you could not move, you could not progress, period. So the government said, okay, from now on, we're going to do something called COTS, common off-the-shelf software. You're going to be able to buy packages and run them, minimum customization, and that the pendulum swung back that way. So you're buying stuff off the shelf and not modifying them, which of course worked for about 6 months before people realized, you know, our accounts receivable are just a little bit different. We need to have it go this way. So what happens is you see swings back and forth. And of course, the fastest code you can write is the code that never acts to execute. So it's one of those nasty things where developers get caught. Well, how do I optimize this? And you have the old timers like me who will come back and tell you, well, optimize it for the poor SOB that has to come after you, who has to keep it working. You might find one optimization that works on today's hardware that's not going to scale in the future. So if you're given a choice between all-out performance and something that is maintainable, go for the maintainability. If you're in a situation where you really, really need that extreme low return time from your application or your function, go for it, but document the heck out of it, because the pendulum's going to swing and it's going to go back the other way one of these days.
Yeah, there's also something else, like between the lines here, as like engineers were not really paid to write code, we're like paid to solve problems. So the way that we do that is like, you know, it's probably specialized and all that. It's important and interesting, but it's important that we're actually solving problems. And if we're doing that with like low code things or writing a ton of code, it's just important that we're doing what we need to do and being flexible in that way.
Cool. So our last question here is just an open one. It's always a fun one that I like to ask, and I think we've touched on it briefly throughout this conversation, but what is the future of web? What do you all see as the future of web? And from any, you know, kind of take that at whatever scale you want, but just curious on your thoughts.
One word: inescapable. I hate to say it, but you know, we all carry these funny little devices, and when they dig up our society, whatever archaeologists in the future find us, they're going to find these little prayer devices that we communicated to our gods with, and they're going to see that we had everything interconnected multiple ways, and there was no way to get away from it.
I definitely think it will be interesting to see how we either adopt or don't ML or AI, right? Because we're already seeing it in lots of different ways incorporated into the web, but we don't necessarily see positive responses to it all the time, right? So I think it's part of the future, but I don't know to what extent, because I think that like there's always a possibility of like pushback, especially when you see how like biased it is, how incorrect it is. But then like I hope that the future of web is more accessible. I think right now we spend a lot of time building things that a lot of people just don't have access to. And I think the more we think about accessibility, the more we build the web for everyone. And so I guess I hope that's part of the future. It's certainly part of what I will be bringing to my like career and encouraging other people to do so, because I think we have a lot of work to do to make the web a safer and like more accessible place for everybody.
I think I see the web, specifically the browser, becoming like even more robust, like runtime environment. The browser, like historically, has been like limited by being like single-threaded and not having like persistent storage and all these things that like HTML5 specifications have like kind of tried to address, and like workers have tried to address like the single-threaded stuff. We have like a limited amount of like monitoring and telemetry data that we can get out of the browser, like windowed up performance and stuff. So I think that we'll continue to see like advances in that way that allow us to have like more confidence and visibility into what's happening in the browser in the way that we do for our backend applications.
I certainly see that web is not going anywhere. That's for sure, right? But that's it, because it has a profound impact on our life, right? And the future human interaction is even today, my interaction, about 80 to 90% of my interaction because of COVID too, but it's through web, right? Because if you look at it right now, we are having this conversation through the web technology today, right now. So that's not going anywhere. I think as a responsible citizen of global citizen, I should say, there has lot needs to be done in terms of how can we use web not to only bring a positive change around the world, right? And make everybody's life easier, including myself, so I don't have to go to the bank to deposit a check, right? But at the same time, there has to be needs to be done on a flip side, where number one, a lot of people do think that they have not ridden this revolution of web, and they have completely left out. And then there is a certain population who completely thinks that web is totally evil. And the answer is somewhere in the middle, right? So I guess that's the thing. When all of us needs to figure out where we draw the line and where we can actually enhance everybody's life together, right? From technology perspective, I think Ted mentioned, right, man, they are getting smarter, right, man. If you look at from Netscape to now, I dare to say Microsoft Edge, but even Microsoft Edge, right? Even Microsoft Edge, it is getting better and better. So at certain point, you will see decline of individual, what we known as a mobile app today, right? You will see that decline as the web market or the browser becomes more intelligent.
It's going to continue to, it's not going anywhere. That's always been mentioned. It's going to continue to evolve. For those of us who were part of the web, when we had to deal with command lines such as whois, host, dig, and gopher. And now we see where the web is today. The web is still a wide open frontier. Individuals need to recognize and understand that as long as we are able to be interconnected, the web is going to allow us that opportunity to be interconnected. As Katie mentioned, hopefully in the future we'll reach out to the masses, more of the masses, those in third world countries, those even in our country itself. Given where we're going through right now with school districts open, we're starting to see situation with between the haves and the have-nots, those kids that are going to be well educated and not left behind, and those that will. So those are the little things within society that are coming out to say, hey, where can we take the web? Where can we go with it? It's a wide open frontier. It's just going to take fresh minds, ideas, and just boldness to go out there and figure out what we need to do with it to continue to evolve it, pushing forward.
Yeah. So I think the future of web, uh, every developer will be asked to write a definition of done, where there will be two test cases. One is to see whether that web page is having all accessibility rules met, and the other is whether the web page is able to be accessed in low bandwidth locations, right? So today, we as developers, we never think about the bandwidth while we develop. We commit the code and we think that everyone will have the same bandwidth to access our applications. But I think the future, we will be giving more importance to accessibility, where we make web for everyone, even they are in remote locations. Thank you all for your views today and taking part of the panel. And thanks, Brandon, who came in with me today to moderate as well. And thank you all for supporting us and supporting JavaScript and Friends Conference 2020. And we hope everyone is having a good learning opportunity today. Thank you all.
Thank
Thank you
you.
for having
Thank you
us.
for having us.
Thank you,
Thank
guys.
you.
Say hi to them at the sponsor booth. They are in Slack all day. You can go visit them and have any follow-up questions with them.
Yes, please do. Thank you.
Thank you.
Thank you.
You're trying to build something great, something that matters. You have a smart team and they want to go fast. Fast means beating your competitors to market. Fast means attracting the best talent to your team. Today, fast is no longer optional. It's essential to surviving and thriving. But you also know that moving fast can break things. You could be just one bug away from everything coming to a standstill. What if you want to deliver quality and be fast? That's where Circle CI comes in. Circle CI helps teams work better together through continuous integration and delivery. With Circle CI, every commit runs through your automated pipeline. This allows you to find problems quickly. So when you do break things, they break small, making for quick and easy fixes before your users see them. And every member of your team can work independently because Circle CI is built to scale. No more waiting in line to get valuable updates out to your customers, or admins fighting through tickets to install a plugin or tweak a build setting. Circle CI eliminates the bottlenecks that slow down your delivery schedule and frustrate your team. Circle CI helps your team focus on what matters, building great things, and not waiting for great things to build. Find out more about how Circle CI can help your team work smarter, faster.
Lightstep is an observability platform that gives developers unprecedented context and visibility into systems, services, and architecture. Just supply Lightstep with your service data, and we can generate insights about its health with no further configuration on your end. Let's say you were alerted to an issue in your inventory service. Instead of holding a disruptive meeting, anyone on your team can use Lightstep to quickly locate the source of the issue. Here, we can see spikes in latency and compare them against periods of normal performance. In seconds, Lightstep analyzes the metadata associated with thousands of requests to determine what correlates with latency, not only in your own services, but in databases, third-party applications, and cloud service providers too. This makes it easy to understand how downstream dependencies affect your service. Continue your investigation by viewing end-to-end requests in real time for any regression, as Lightstep analyzes 100% of your unsampled event data. It automatically highlights the critical path and surfaces the relevant attributes to help you resolve performance issues faster. And you can easily share these insights with your team, all from within the app itself. Included in our analysis are the runtime metrics collected during the regression window to show you how they may have influenced performance during that time. While investigating an issue, you can group, filter, and sort regressions by service, operation, and tag. For example, Lightstep can show you which customers are affected and how badly. With this insight, it's much easier to prioritize performance optimizations and workflows for incident resolution. With error analysis, you can see exactly where errors are occurring in your system and view automatically generated insights, like which tags are most correlated with errors. Deploy more confidently with Lightstep's Service Health for Deployments feature. Lightstep will automatically identify deployments and provide information about any resulting regressions, so you can resolve them faster. Plus, with support for canary deployments, you can monitor the impact a new partial release has on overall system performance. And unlike conventional APM solutions, Lightstep is purpose-built to scale with your organization. So no matter how your system evolves, Lightstep will keep up without slowdowns or upcharges. Ready to learn more? Try Lightstep for yourself by checking out our sandbox demo at lightstep.com/play.
My name is Ted Pennings, and I'm going to be talking about testing data visualizations today. I'm going to be talking about how we can use tools like Hapo and Cypress to test that our data visualizations are accurate and correct, to test that they adhere to our product specifications, and of course to test that they actually load and that they work. So here's the agenda. We'll be talking about the tools, Cypress and Hapo. I'll do a quick tour of data visualization just to make sure we're talking about the same thing, different chart types and so forth. Then I'll talk about how to test data visualizations, and then I'll talk about how to test interactions with data visualizations, the things that actual users would do. Okay, so let's start with the intro. Who am I? I'm a software engineer. I have a front-end focus. I write lots of React code. Been doing data visualization for like about around 4 years. I've been writing tests the whole time that I've been writing code. I feel very strongly about writing tests. I live in Portland, Oregon. I like plants and flowers and do some gardening. It's me over there with some peonies and roses. So this is not a marketing talk. I don't work for Cypress. I don't work for Hapo. There are alternatives to Cypress and to Hapo. This isn't a marketing talk at all. I'm talking about how you can use these tools to test your products and your software, but there are a lot of ways that you can do that with other tools and so forth, and a lot of it is like the general approach. All that said, I do believe that Cypress and Hapo are excellent and the best at what they do. Okay, so Cypress and Hapo. Cypress is a browser-based testing tool. It drives a real browser. It drives Chrome most of the time, the exact same version of Chrome as you use and your users use. It's JavaScript code. It's like very JavaScript. It feels like JavaScript. It's like very ergonomic in that way. So you write this JavaScript code and it does things to a browser, and you can assert things based on what's on screen and like grabbing values off the screen and so forth. It's open source and free. There is a paid add-on, the Cypress.io dashboard service. It has a lot of good reasons to use it. It enables test parallel, all right, that word, and that saves us about 12 minutes per test run at Lightstep, from 16 to 4 minutes. They also added some like analytic stuff for most commonly failing test cases and longest test cases and stuff. So this is a basic Cypress test. In this test, I going to a website there on that site.visit line. I'm logging in, and then I'm asserting that there is a chart that's visible, specifically that like get by test ID. It's a shortcut for getting an element, and it's a custom command, and that will find that specific element based on like its DOM attributes, and then I'm asserting that that element is actually visible in the browser window at the moment that this test runs. So there's a Cypress talk coming up next. Jordan Powell is giving a talk after this, automated testing, all the things with Cypress. Definitely go to his talk. I think it'll be really great, and I'm looking forward to hearing about the way he uses Cypress. I'm going to be focusing on data visualization and interaction testing. I'm not really going to be talking about Cypress broadly. There are a lot of things I'm skipping over, like authentication, how you use Cypress against different environments, dealing with feature flags, how you set it up in CI. There are also some like best practice things like that command I showed before, and like the use of commands in general. I'm not going to talk about that a ton, but I'm happy to discuss any of that in the chat after this talk and after the next Cypress talk. I'm looking forward to getting to talk with all of you about how you use Cypress and questions and all that. So Hapo. Hapo is a screenshot testing tool. With Hapo, the test is a visual diff. If you like imagine a code diff, the test is like a visual diff in the same way. So this is an example here. You can see this test over here, the cursor moving. I changed a chart from gray to magenta, and Hapo caught that. Maybe I didn't mean to change it to magenta, probably didn't mean to change it to magenta. So it's nice that Hapo caught this change, and you can see the before and after with that nice swipe. You can also review it. Yeah. So this is a paid service. It's not free. It's like a regular product. I've found that it's like a very like reasonable price. Like the cost of it didn't even come up when we were considering it at Lightstep. All right, so I want to do just a quick tour of data visualizations, like 2 minutes, just to make sure we're talking about the same thing. So, and we talk about that. There are some basic chart types: line chart, area chart, bar chart, spark lines. So let's just look at those super quick. So here's basic line chart, nothing fancy. This is an area chart. It's basically the same thing with like a gradient below it. But when people talk about an area chart, they usually mean this kind of chart where the areas are stacked on top of each other. And you can see here this like orangish color, AMT. Its value is 2500 at this point, but it's well above that level. It's because it's like stacking on top of others. Then there are also bar charts, just sort of normal bar charts. I think I mentioned spark lines. These are spark lines. They're basically tiny line charts, usually with fewer points. And then there are some kind of fancy chart types, like a histogram. It's essentially a bar chart, but it shows the distribution of things. So in this example here, for that highlighted bucket, that highlighted bar, it shows 21.8 milliseconds to 23.6 milliseconds, and it shows the number of spans, the number of like events that took that amount of time. So this is showing the distribution of how long things took. And then there are also some chart types that are more like graphs, like network diagrams and org charts and that kind of thing. Those come up with a lot of forms of data visualization here too. So this is showing the relationship between like operations, between functions and service calls for this particular thing with errors. So this is another type of visualization. All right. So we went over all these. X-axis, y-axis, that's pretty much always there. X-axis is very often time for like a time series chart. Cursors and tooltips are really important. We're going to talk about that later. From my experience, they're usually the hardest part of making a chart, both like formatting the data and all that, but also like the interactions that a user has with them. I mentioned there are some other forms of charts, like the vanity graphs, that like diagram I showed with the red circles, network diagrams, sports brackets fall into this category too. They're very much a chart and a data visualization, like all of the other things we're talking about. So let's talk about data visualization interactions. The most common, of course, is like hover. That would involve like a tooltip and a cursor that like shows you the values of the chart and so forth. It might also do some things with adjacent content, like highlighting like rows of things or showing data in a table for those values. I'll be specific about what I mean there. So I'm talking about this here. So I'm like hovering over these things in this sidebar, and it's changing the specific items that are highlighted above. There are also click interactions. That's, just maybe toggling lines on a chart, opening a pop-up. There might be like starting a selection. Click and drag, I think, is like very, very common and kind of hard to test, but I'm going to show how to test it. So zooming would be an example of that, panning to like move around on a chart and all that. Filtering, rearranging things. Those are all actions that you would do with like a click and drag. It can be kind of a lot. Keyboards doesn't really come up a lot with data visualization. I can imagine in like a very large chart, like using the arrow keys to like move around left and right, but that's, I don't know, I can't imagine a lot more. Mouse out and blur, those are really important. When you leave the chart, you want to make all of the chart junk go away, all the tooltips and all that stuff. Like you don't want that hanging around. Okay, so let's talk about how to test data visualizations. So where do we start? First of all, what do you want to test and what do you need to test? Often there's a big difference between those two, and a lot of it also has to do with like what your responsibilities are and what the responsibilities of your colleagues and other teams are. So questions to ask: do I need to test the accuracy of the data? If I'm just building front-end visualizations that display something that comes from an API, do I need to worry about whether the data is accurate? Or is that something that the people who are storing the data and giving it to me, is that something that they will take care of? Do I actually own the data is another way to put that. Is mock data sufficient? Maybe it is, very often it is, but sometimes it's hard to get like meaningful things out of mock data. Things that you might not expect can be avoided in mock data because it's like very controlled. Then do I need to test the usability or availability, the end-to-end flow? So that's like elevating the test beyond like the level of like, do these lines look correct? Are these like the correct colors? Is like the data being plotted correctly? Now we're talking about like, do my charts work after I deploy my code every time? Like, can I check that they're working at like any point in time to validate that everything's good? Another question to ask: how often will these tests run? And who will know when they break and who will fix them? These are questions that come up with all kinds of tests, and these data visualization tests and end-to-end type tests are exactly like that. So not to leave a bunch of questions without some answers, this is what we do at Lightstep. We run all of our tests on all of our front-end code changes. Every commit, every PR, all the tests run on that. We run all the tests after every deployment too. We have automated deployments to our like staging environments, and then manual ones up above that. And after those tests, we after those deployments, we run all the tests. It just takes a couple minutes, and it gives us a lot of confidence. And it's also very fast. It's faster than us like doing the manual QA. It just goes out and validates everything. We use a mixture of real fake data and fixtures. By real fake data, I mean that we have like a very predictable like random data generator. It produces data that looks a lot like what our customer data would look like. It's very predictable in that it produces like the same kind of shape of data, but there's like some variability in it. It's what our salespeople actually use, and our tests, our Cypress tests, use that too. So when we test our software using Cypress, we're also testing the demo flows that the salespeople use, and that's been really great for just ensuring that we have a lot of confidence. There is a sandbox where you can sign up. You can see how our product Lightstep works, but you can also see what our fake data looks like, and you could even go like inspect and look at our data test IDs and all those things if you want. So let's write some tests. Let's test a line chart. Very basic chart. These are the things that I think are important to test. That it's visible, that it's on the screen, that it's loaded without an error, without a timeout, and that it's rendering data. We'll get to what that means. But yeah, so visible, that it loads without an error, that it renders something. We're done. This is one of our actual tests for that kind of thing. So we're going to a page in the application here and a little before each block, logging in and all that. And then we are testing that the charts load with data, specifically these 3 charts. So we're getting the chart element, and then we have a custom function to assert that the chart has data. I'll show that function in a second. But this tests that when we log in, when we go to the place, there's a chart, it's visible, it's loaded, it has data. So what does that function actually do? Seems like a lot of magic, it's a little bit too short. So what does it mean for a chart to have data? And how specific do we want to be about that? The test that I'll show you, it has like a complicated squiggles sort of view of what data should look like. And if you look at this, it's basically squiggles. They're, like pretty like uniform. There's a pattern, but there's some squiggles going on. So is complicated squiggles a good enough assertion? Let's talk about that. For this particular command that we wrote for this assert chart has line data, yes, complicated squiggles is actually what we're looking for here, because there are a lot of different things that we're trying to test, and that the chart loads and that it has something that looks like data is what we want to test, that it has data-like contours. And that's just one kind of test, one like aspect of the testing strategy. But I think it's an important one, and that's something that we run on every single commit and every single deploy, because we want to be sure that charts load and there's something data-like. So this is what complicated squiggles looks like. It's a Cypress command, a custom command. So this is the syntax for adding a custom command. That assert chart has line data command name. It operates on an element that it's been given. So what that means is that assert chart has line data operates on the element here, the latency chart element. And given that, there's a get. We use recharts at Lightstep. It's a really good charting library. I recommend it. So there's a get to specifically find the SVG path within that container element that we were given. There can be more than one, so we grab the first one, and then SVG paths align have a D attribute, and the D attribute is this like crazy string with like a lot of capital M's and like just a bunch of stuff. It's like point here, move to here, point here, move to here. It's there's a lot to it. So we're testing that there's a lot to it. We're testing that it's a complicated squiggle. Specifically, the attribute D is a string, and we're testing that that string should have a length of at least 2 kilobytes of data. So complicated squiggles is cool, and it definitely has its place. It's a really fast and easy assertion, so I think you should use it a lot, but we've got to do better. If my product only loaded with complicated squiggles, you wouldn't want to buy that. You want something better than complicated squiggles. So what do we need to test? We want to test the data loads every time. We've got that with complicated squiggles, check. We want to test that the data is actually accurate. I think this is the most important test. This is like the reason why we're here right now for this talk. And we want to test that the data is formatted based on our product and design specifications. We don't want like Magenta sneaking up on us like it did earlier. So we test all of these things differently. Hapo is actually going to help us a ton with testing these two things. Hapo is going to be the answer to testing these two things, at least in the way that I approach this problem. So to get to that of what Hapo is, first I want to just mention that like Hapo is most often used with Storybook. React Storybook is a way to get like an encyclopedia, a compendium of all of your like UI components and elements and widgets and like all your React things. You can create a story like what's going on here for any of them. Maybe not all of them because there's like a little bit of expense, but definitely for a lot of them, you can create a story like this. And you can put different props in those elements to represent those different UI states. So here, I'm creating a story for the success state of this chart. I would also recommend testing error and empty states. Loading can be tricky because of like animations and stuff. We're talking about like visual diffs with screenshots. So if there's an animation, there's always going to be a diff, and that test is not going to pass. So now that we have Storybook, we can get PR diffs. You can see here that there is a Hapo GitHub status check, one diff, a bunch of other things that aren't changed. And here is the same thing I showed earlier with that chart that became magenta. We didn't want that. We didn't expect that. So that was a PR check. Hapo found this change in the code from that PR, caused this failing Hapo check, and alerted us to the issue. We could also go review it, and you can click accept here if you do want your charts to be magenta. There is some plumbing required to make this happen. There's a lot of really great documentation on how to do this. I think the major plumbing is actually in Storybook. The Hapo side of this is pretty straightforward. And I have to give a shout out to all my colleagues at Lightstep who've done the work to plumb this up. It works really great for us, and I know that they spent some time working on that. So with this test, we can have confidence now that our data, our charts, are formatted based on the product and design specifications. We can see what happens when we deviate from the specifications. Specifically, our PRs have a failing check that cause us to go investigate it. And if it is a warranted change, we can accept that and have a green PR check. But now we have a test that our data is formatted properly. Next goal. Data is accurate. We need to ensure that the data we display is an accurate representation of the data that comes from our backend source, whatever that is. Specifically, like given that data, we want to make sure that we chart it properly, that the lines look right and all that. That's, I think, the most important thing to test. You don't actually have to test all of it, though. First of all, I don't think you have to test it on every single commit or deployment. You can have like fixtures that repeat the same data. In this test here, we have just fixture data. And given that input fixture data, we can test that it's transformed properly. One thing here that's out of scope, we don't really want to repeat the testing that another team is going to do. If there's another team that owns the data, if they own the backends and all that, we don't need to test their work. We can trust that they're testing everything adequately And if that's not the case, that's a different problem and a different talk. So let's not focus on testing things that are outside of our control too much. So as you can see, HAPO is more than a styling test. Here I did some stuff to the math, and specifically to the transform from like the backend data format to the thing that's actually charted. And you can see that the bars kind of changed. They still have the same shape, so we might have like easily missed that. But you can see, like for example, on this y-axis here, that the 1000 turned into a 1200. So everything kind of shifted up a bit. Our data is not accurate anymore. So to make this happen, we're using stub data, just JSON files with like the big blobs of data that you get from like an API response. Ideally, these would be like very realistic. So if your charts have like a bunch of lines, like a very multi-series chart, you should definitely have a storybook entry and a HAPO test with a bunch of lines. And if you have like kind of weird things with like one giant line and a bunch of little lines, that's kind of important too, because you might like easily lose that like resolution on the little lines, especially if you made some changes to like your like stroke weight or something like that. So think about all the variants that your charts would have based on the shape of the data, and also what a user would like ask about, what a user would wonder. Make sure that you have that covered too, because you want to cover this as like a form of unit test, but also as a form of user story testing. So with this, I think we can have confidence to say that the data is accurate. With this example back here, with the chart changing, we can see actually that even though the data looks basically the same, it's changed and our charts are no longer accurate. There's something wrong here. There's something that we want to investigate. And in this specific example, we would get a PR check that fails. We would be able to go look into it and see that our screenshot test has failed. We could see exactly what we're looking at here. So you might want more control over this. There are some limitations of Storybook, like specifically it is it's not like really a browser. There aren't any like interactive components. You can't like click or like do any of the things that a real person would do. So you can use HAPO from Cypress. There are other plugins actually too. There's like a long list. There's a Cypress webpage for visual testing. There are like 5 different plugins and vendors for this, but sticking with HAPO, I really like HAPO. You can use HAPO inside of Cypress. There's a really great package from HAPO that makes that possible, and this is critical whenever you want to manipulate state as part of your screenshot testing. What I mean by that is, like, if you want to hover over a chart and see a tooltip, and that hover is a mouse event, that's not something you can easily do in Storybook, at least not as far as I know. So you would do that in Cypress. You would hover over the chart and have a screenshot, and I'll show that. You want to make sure when you're doing that you use fixtures for everything and that everything is completely repeatable. Thinking of that like loading spinner animation example I was mentioning earlier, if you have like the slightest change in your data, HAPO is going to pick that up, and you want that. So you need to make sure that your data is exactly the same when you're doing this. Use fixtures for everything. If they're animations, you definitely want to wait for those. A lot of charts, when they render, the lines will like go up and like do some things. You want to wait for those animations to end. And here's how you take a HAPO screenshot. It's just a HAPO screenshot command. It's like very, very ergonomic. You just invoke that on an element and it takes a screenshot. And you can pass in a variant which like gets added onto the name of like the Hapo test case, essentially. So I want to give a shout out to my colleague Dan Diaz at Lightstep. He set all this up for us, and it's been like incredible. It's changed the way that we do our testing. So many thanks to Dan. Quick recap. So we've got a few things we want to test. We want to test that the data loads. Cypress is perfect for that. We can test the data loads in our like local controlled environment. We can run that test against like a production environment. We could even run that test against customer data, and we could run it as often as we want. We could use the real backends, or we could use fixtures in the case of fixtures, or like testing that like the plumbing from like the fetch request up to like the chart pixels. We're testing that. So that's data loads. Testing that data is formatted properly. That's, I think, actually a really straightforward test when you use Hapo and Storybook. I should have mentioned there are other like screenshot things for Storybook too, like Percy and stuff. But I really like Hapo, and they make this like dead simple. You get the PR checks that are really nice. I think it's the best approach to that. Next test, data is accurate. So this is where we have to specify what we mean by that. If we're looking at like stub data, fixtures, and all of that, Storybook is like great for this. It's fast. If we want to test like something like more like nuanced, that is something we might test with Cypress if we have like interactions we need to do on the data before we assert it. You could also do basically the same test as the Storybook test, where you just have the element in your app on like a page or whatever, and you use fixtures to control the data going to that. Those approaches will test that your data is accurate. All right. So we've talked about testing data visualizations. We've talked about how to test that your data loads, that it's accurate, that it's formatted properly. Let's talk about how you test the user interactions with that data, because that's extremely important, and that leads to like the stickiness of your product, that people wanting to like come back and use your product over and over again and find something useful in it. So I'm going to show how to test a couple real user interactions, specifically hovering on a chart. When you do that, you usually expect a tooltip, and we want to make sure that that happens. We also want to test when you like click and drag on a chart, because that's like a super common chart interaction and like very important and useful. The thing that happens when you click or drag, that's like up to your product. That's not like specific to the test. And I guess you could say the same thing about hovering too. So without the tools that we've been talking about, without like Cypress, without Hapo, it's basically untestable, these two things. Hovering on a chart shows a tooltip. Like, how are you going to test that? I mean, I guess you could test it like with Selenium, with like a bunch of like selector things and all that, but that's really the only way that comes to mind for me. I think it would usually be a manual test, and clicking and dragging and having that do something interesting and being able to assert the visual state during and after that interaction is definitely not something that would have been available to us before these tools. These are also interactions that people care a lot about. These are like at the heart of your product. They lead to that like stickiness I was talking about. They're also really important when you're showing someone the product for the first time, because it helps people get excited about what they can do. So you want to make sure that those things work. Hover. Hover's a little tricky. Cypress can simulate JavaScript mouse events. There's a sci.trigger function command, and the sci.trigger command, you give it an event. You give it like all these mouse events that I've listed. You can give it like other, like basically anything you would have like a document add event listener for. Any of that, you can have a sci.trigger. You can also trigger click, but sci.click is like meant for that, and there's a lot of other like good stuff going on with sci.click. So don't click with trigger. And these mouse events can kind of get nuts, as you can see here. So when you're doing this, it's really important to check your targets. I'll show what that means in the next slide. But when you fire a mouse event, if you fire it at the wrong target, it's not going to do anything. And you're going to wonder if your code doesn't work, and you might forget that your test doesn't work. That happens to me a lot. So check your targets, make sure you're triggering things on the right element. Also, the JavaScript mouse events are pretty like easy. Sci.trigger makes this like really easy. But the CSS mouse events are pretty hard in Cypress. There isn't like an out-of-the-box support for triggering like a CSS pseudo-class like hover. There are some options involving some of the like kind of lower level testing APIs that Chrome exposes. But I think it would actually be a lot easier if you're going down this path to just use like invoke show or invoke CSS. There's also commands. The value here is the jQuery function name, and then it takes the arguments that the jQuery function name would take. That's how the invoke works from Cypress. Use that if you can, or like see if you can avoid hover, because that's kind of tricky. Hover test. So we're here. All right, we've got these lines. We've seen them before. We've talked about them a lot. Here's the tooltip over here. And we have these numbers in the tooltip. We actually care a lot about those. That's an important aspect of this. And we want to assert that it appears, first of all, that it appears in the right place. We could also assert that this cursor here appears. This tracks the mouse, so you know the current time on the chart. That would be another like really great thing to test. So here's what a test like that could pretty easily look like. You could have a test that chart tooltips are being displayed. So you're going to get the element using sci.get or this helper thing that I like. We have a custom command to find chart surfaces. All of our charts are SVG, and there's like some layering stuff going on with recharts. So this command basically returns like all of the lines. You can just think of it in that way. And then we're taking the first one, and then we're going to trigger these mouse events on it. So that will make the tooltip appear. And then we're going to get the element for the tooltip, make sure it's visible, and take a screenshot. So this test has tested that when a user hovers over a chart, the user sees the tooltip, like it's visible, and we also have a screenshot of that tooltip that we're going to use as a HAPO test. So to make that work, we need fixtures. But as part of that, we actually get like a unit test from the HAPO screenshot. These numbers over here, they shouldn't change because you're using fixtures. All of this stuff shouldn't change. So you're testing the formatting, of course, you're testing that the thing is here, but you're also testing the accuracy of the data, or at least the accuracy of the data as it's like presented through the UI from the fixture. So there's a lot going on here, and it can actually be really short. You can imagine this is sci.get up here. So we only have like one custom command. This could be like sci.find G. So we're not doing anything crazy here. HAPO screenshots provided by the HAPO plugin. So this is actually pretty easy. drag. Drag is not as easy. So drag is just another mouse event, and it's specifically like a mouse down as you click, a mouse move as you're dragging, and then a mouse up to complete the drag. So this part of the Cypress test is like really easy. It's basically the same as what we saw before. It's all this other stuff up here. So here, this is an actual test for that like blue histogram I showed earlier with like the distribution of spans and stuff. We're getting that element, and specifically when we do this L0, where we're getting the actual DOM element, not like the Cypress wrapper around it. And we're getting the bounding client rect, the geometry of it, and then we're calculating where we want to perform our click and drag. So we start the drag like 25% over. So if you imagine like we've got like a number line here, like 0. So we're starting at 25, click and drag over to 75, let up. That's what we're doing here with this. And then that drag is happening in the middle of the container. So once you get past the math, this is actually really easy. And this is basically the same thing as what we were doing before. And here in this test, the thing that we care about is that when you click and drag on this histogram, that we set these like min latency, max latency bounds to like highlight the specific area that you've highlighted. So that's drag. Yeah, I think there'll probably be some questions about it in the chat. I look forward to that because it's like it can be really easy, and then you get to the math. There's some other cool Cypress interactions. So there's sci.viewport. You can use that to set the size of the browser window. You can actually call it a bunch. So you can use it to ensure that your page is responsive and that it expands and shrinks as the user changes the size of the browser. This couples extremely well with Hapo screenshots. So you can do a screenshot test of like the expand and contract, and if it works, they'll probably look the same. But if it doesn't work, you'll see that like elements might be like overflowing their containers or not shrinking or whatever. Sci.scroll to is another one. It would be like really great to test virtual scrolling, like infinite scroll. With this, you can like scroll down to an arbitrary amount, and then you could use like regular Cypress assertions about like elements being visible in attributes and stuff, or you could use Hapo to assert that too. It's like a level of interaction and control that I don't think is really available outside of like this style of testing, outside of like Cypress. Scroll into view, it's a function, it's there. You often have to call it if you're like trying to interact with something that might be below the fold of the page. Call it, definitely. It has scroll in the name, so that's why it went up top. There's some staples here. Sci.type, it's what you expect. You can use like other things like this. Sends like a right arrow keyboard event. It types a right arrow. You can also send sci.type on any element, so you don't have to be in an input field. You could like check that like your chart zoom pan situation works well with arrow keys. There's a bunch of click events, some check and uncheck things, select. Yeah, so lots of great interactions with Cypress. So that's it. Thank you for all of your time. I really appreciate it. I owe many thanks to JavaScript and Friends organizers for setting this up and inviting me to talk, and also to the great front-end engineers I work with at Lightstep. It's been really exciting to be be working with them on so many things. And of course, to the other people who've taught me about testing, like throughout my career, I worked with some really great people over the years, and I'm thankful for everything I've learned from them and hope to pass on as much as I can. Thanks.
Hey everybody, welcome to my talk on Cypress titled Automated Testing All the Things with Cypress. My name is Jordan Powell. I'm excited to not only give this talk, but also answer any questions you might have after the talk here in the chat as well. Let's see here. Okay, so first question asked is, and the first thing is we want to start here is because why do we need testing? Because everything I'm about to share, if you don't believe in the power of testing and what it can do for yourself and for your team, all these things are sort of useless for very impractical for you. So I wanted to share for those of you who may not be testing or only doing certain parts of testing, I guess why testing can be a valuable, something valuable to lean on as you begin to continue to work on your applications, create new features, fix bugs, those sorts of things. Because at the end of the day, our time as developers and really as humans is the most valuable resource we have. Everything we do in life, we exchange time for it, and so when we write tests, we want to make sure that the time we spend to write them, that we have a positive ROI on the other side. Because if not, we're wasting our most valuable asset. So the first thing I think to hammer away at is that testing provides really, it's sort of like automatic documentation. So as you begin to write tests, you are actually in a lot of ways documenting the behaviors of your application. I know, like, as you begin working, if you work on a large scale like enterprise application or something like that, where you work on certain parts of an application with a large team, or even if it's just a project that you're tackling by yourself, that maybe you're spending months or years on, eventually you sort to lose scope of the certain parts of the application, and testing provides a great documentation so that you can go back and say, given this, this is what's expected. And I know, like, for me, there will be parts of my apps that I'll be like, I have a good name, I'll be like, do this thing, but sometimes I'll ask, like, why am I doing this? And then if I go to my my unit test or my intent test or something like that, then I'll be able to read, given this property pass into it, we're expecting this behavior to come out the other end, or whatever the instance is. Testing really provides documentation that I think that from a developer and from an analyst standpoint, I think certainly can provide value. I don't think it's the reason why you write tests, but I think it definitely is a positive part of that ROI we were talking about. One of the things that I think that I feel like is maybe one of the strongest candidates is that it provides you confidence. So as a developer, you begin to write code, and obviously the more code you write, the more confident you get that what you're writing works, right? The more you implement, once you start implementing TDD, and the more you actually implement a TDD or test-driven development approach to development, you'll notice that I've heard it said where when you first start off as a developer, you write code and don't know why it works, but then the more seasoned you get as a developer, you write code and you're like, I wonder why it's not failing. Like you begin to switch your perspective, and I think that where TDD helps change that game is you write a test, it begins to fail, and then you begin to you write code that implements the requirements that you had already wrote in your tests, and you write them until they pass. And the more you begin that cycle, those passing tests they really become confidence for you as a developer, confidence for you, for your team, confidence for maybe your QA team. Really just confidence knowing that whether it be the code that I write or someone else on my team wrote, if it's passing the tests, then there's a much smaller likelihood that it broke something else in my application. So obviously confidence is a very important part of that equation. Obviously, another one is safe refactoring. So refactoring is an inevitable part of development. Requirements change. You may be part of an instance where you over engineer something or you under engineer something, and you say, let me refactor this, so I add an abstraction or maybe I remove an abstraction. Whatever instance you find yourself in. I've never been on any size project of substance where refactoring wasn't definitely a part of writing the application. And with tests in place, you can safely refactor your code, knowing that as you begin to refactor and pull and move parts of your application elsewhere, your tests are going to fail. But once you get them all in place again, they will all pass again. And so just knowing, and it sort of leans into that confidence of you have the documentation in place, you have the confidence that the features that you wrote previously work. Now when you refactor, you now know when you got the parts back in place again. And then finally, an improved UI. So some of the things that we'll begin to show you here later on in the talk is some of the ability with Cypress to, like an end-to-end scenario, test the differences between browsers. So with testing, you can get an improved UI, or in some ways even just more confidence knowing that this button you added, or this animation you created, or whatever your scenario is, that it not only looks right on the screen every single time, but it also looks the same way from one browser to the next. Certainly an important part of the development. So here is something I would like to share with you. So a lot of you are probably familiar with, there's different names for it, but I just call it the testing triangle. And essentially here we have a pyramid that sort of represents, I guess, the scope of automated testing. So in the bottom we have unit tests, which are really the most common form of testing. And if you're not doing any testing, it's definitely the first place I would recommend you start testing. And they are the perfect place to start because you are really just testing one individual part of your application. Typically it's going to be, one class or one function or one method on a class. Basically, how does that one unit or that one piece of code you're writing, does it actually do its individual responsibility as expected? Unit tests are going to be small. They're going to be very cheap to write. They're going to be very quick to run. So ultimately, that's going to lead to a high volume. So your application is going to have a lot of unit tests, because not only are they're obviously very valuable because they provide the confidence that the parts that you're building work, but they're also going to be really fast to write and fast to actually run them themselves. On the top end of the spectrum, you have end-to-end tests, which are going to not just test one individual unit, but it's going to test all of the units of a subset feature or behavior of your application from one end to the other, hence end to end. And it wants to make sure that given the user, creates a blog post and then types in here and does this and then deletes this and then saves and then reroutes here, like it will actually test the full end to end more like a manual test to make sure that, as you begin to build your applications, that from end to end, everything works as expected. Obviously, at the top of this triangle, it's much smaller than at the bottom. And so part of that is for multiple reasons. One is that you're going to have a lot less end-to-end tests because mostly because one, they're going to be more difficult to write, so they're going to cost you more, and they're going to be slower to write, or slower to run. So because they're more expensive to write and because they're slower to run, you aren't going to write as many of them, and ultimately you will want to use unit tests and integration tests to leverage other things and just use end-to-end tests to test specific scenarios that are hard to test otherwise. So I think these separations can be confusing at first, but I think that the more you get into it, just start with a unit test, and then when you have multiple units that communicate and interact with another, that's where you get integration tests, where one unit connects with another unit. So one component interacts with another service, or one component interacts with another component, or this service calls this other service, or so on and so forth. So integrating two parts together, testing how that integration connects, that it works every single time, the exact same way every time. That's an integration test. It's sort of it's more than a unit test, less than end-to-end test. So it's going to be more difficult to write, a little bit slower to run than a unit, but less than end-to-end. So you sort of have this sort of increased level of complexity and expense for every step of this pyramid. The other thing to think of is a rule of thumb to consider is that with these tests, it's like the factor of 10 is what I like to call it. So you're going to have, say in an application, you're going to have thousands of unit tests. You may have 1,000 or 10,000, or you're going to have several thousand typically on an enterprise application. With that being said, you'll probably only have hundreds of integration tests because there's a lot more units in an application than there are integration between those units. And if you have thousands of unit tests and hundreds of integration tests, you may have only tens or dozens of end-to-end tests. So just to, again, keep in mind for those who aren't familiar with sort of what type of tests run what, that's sort of some general guidelines. And if you aren't doing any end-to-end tests or integration or unit tests, certainly love to help answer any questions you might have after this talk. So here's I love these GIFs. I see them all over the internet. They're super funny. But it just shows the door and then the swinging arm, those things could be independently unit tests. Those units work as expected, but when they're put in correlation, in connection, when they actually integrate with another unit of the, in this instance, the system or your application, they begin to definitely not act and behave the way you intended them to do. So it's just a funny way of showing the need for more than just unit testing. So let's get started with Cypress more specifically. So Cypress, for those of you who don't know, it's a next generation front-end testing tool built for the modern web. It addresses some of the key pain points that developers and QA engineers face when testing modern applications. Cypress in particular, it can write end-to-end tests, integration tests, and unit tests, so it can test all the different types on that testing pyramid. But Cypress really focuses and provides a complete end-to-end testing experience. So Cypress can test anything that essentially runs in a browser, but its real focus and bread and butter is providing you with an easy, quick end-to-end experience. So it knows that there are other other testing tools out there that run, like Jest and Karma, and, that do end-to-end tests or unit testing and, integration tests and other things well, whereas end-to-end tests have primarily been very not fun to write. And so that's where Cypress really comes to the rescue. So I guess why Cypress? Like, what makes Cypress different than other applications? So number one is that it does not use Selenium. So most end-to-end testing tools are Selenium based, which means they essentially share the same problems. Cypress is different because it's built on a new architecture, whereas a lot of the other ones were built on Selenium, and essentially Selenium executes commands actually through the network, where Cypress runs in the same run loop as your application itself. So Cypress is like a wrapper around the actual browser instead of trying to sort of execute commands through the network. Cypress actually it wraps your application, and therefore it has access to really the entire scope of the browser itself. We'll get into more specifics of that. Cypress focuses, like I just mentioned, on doing end-to-end testing really well. So it's not a general automation framework, nor is it a unit testing framework for your backend services. Though there are, like I mentioned, there are other great tools that do that, but rather instead Cypress really focuses on making and writing end-to-end tests for your web application really as simple as possible. Cypress works on any front-end website or framework. You can test anything that essentially would run in a web browser. All the architecture surrounding Cypress is built to handle any modern JavaScript framework, as well as any in the old like server rendered pages or applications, but certainly whether it's vanilla JavaScript, React, Angular, Vue, Elm, etc. It will do an amazing job at testing them. Cypress itself is only written in JavaScript, so while you can compile down to JavaScript from any other language, ultimately the test code of Cypress is executed inside of the browser itself, and therefore there are no like driver bindings, and basically it just makes it a little bit more simple. And they have also really like made that promise that JavaScript is and will always only be what is used for doing that. Cypress is an all-in-one tool. So typically in the past, in particular, writing end-to-end tests would take a lot of different tools working together. Well, with Cypress out of the box, you really get bootstrapped multiple tools in one subset. So there's no need to install, a dozen separate tools and libraries to get your test suite set up. Cypress took that time to basically wrap all those things into one library to provide really best-in-class tools that you are already familiar with and able to use, and they really just work together seamlessly. Cypress is a great tool for both developers and QA engineers. So this is one of my favorite things is that it's not just for developers or just for QA engineers. I feel like it makes it work for both people in a pretty easy way. So I think that that's always nice when you can kind of have some cohesion and buy-in from both of those units on your teams. The other major thing, obviously, for people who have ran or run in tests before, they could be very slow. Cypress runs much faster than the tools that you have maybe previously used. The architectural, because of the architectural improvements that are built with Cypress, it really unlocks one of the greatest things of Cypress is the ability to do TDD with end-to-end, which hasn't really ever been possible before. Cypress was built so that testing and development can happen simultaneously. You can develop faster while driving the entire dev process with tests, because you can see your application. You can still have access to the developer tools. Changes are reflected in real time. The end results is that you have developed more and that your code will be better and that will be completely tested. So you can actually end-to-end do TDD, which we do a lot of unit test TDD, but not really end-to-end testing TDD. So you get a new if you're on a sprint team, if you get a user story, you could literally test out that user story. A user clicks this button and then this happens and this happens, and then at the end we're expecting this. You can actually write a unit or an end-to-end test in Cypress and then TDD the process until you see that passing in real time, which is really cool. So here are some just high-level features that Cypress, I think, really does well at and kind of sets itself apart from other frameworks. So Cypress takes snapshots as your test runs. So simply, you just hover over the commands in the command log, and you'll see exactly what happened at each step of the process. So if any of you have used a tool like Redux before, and you have the Redux dev tools where you can time travel every action that was dispatched into your reducer, you get that same sort of behavior with Cypress, because you get the time traveling where you can see every step of the test. You can go back and see a snapshot of what the DOM looked like in that. So I think that's a very cool feature. You get real-time reload. So every time you make a change to a test in Cypress, it will automatically reload the app in Cypress. Here's another thing I think that's very underrated part of our feature of Cypress is the debuggability of it. You get very readable errors, which depending upon other frameworks you're coming from, very difficult to read some errors from some of these frameworks. But with Cypress, they're much easier to read, and you get that debugging directly in the Chrome DevTools. So because Cypress is built around, it really wraps the browser itself. You just literally open your Chrome DevTools or your Edge DevTools, and you have that debuggability to see network requests, console errors, all those things directly inside Cypress. Automatic waiting. So this is one of the big pain points with Selenium-based applications, is that you had to add a lot of waits for your commands, because there would be sort of like race conditions where you're waiting for this request to come back, or you're waiting for this animation to appear on the screen, or just the way the DOM would interact with other parts of the DOM. You would have to add these waits so that you wouldn't have this issue where you're waiting for one part and then it would fail because it needed another 300 milliseconds for that thing to actually appear on the DOM. Well, Cypress automatically waits for commands and assertions before it moves on, which is very, very nice to not have to do that. You have the ability to add those in, and we'll see it here with SPI, stubs, and clocks. So you can really control the behavior of your application. So whether it be a Lambda function from a cloud server, or a server response, or some type of timer, it really gives you like the same functionality that you love when you write unit tests in your fingertips for end-to-end testing. You get network traffic control, so you can easily control, stub, and test edge cases without even involving your servers. So you can stub network traffic however you like. and we'll get into some more examples of that, but some really cool things with that. Constant reliability. So I mentioned before with waiting and all the different parts that were really a headache with Selenium or WebDriver, you just get much more consistent, faster, reliable, and flake-free tests, which definitely, there's nothing worse than you merge your feature or a bug fix into master or production, or however your process is set up, and you run it and you get some flaky end-to-end test that fails, and you rerun it and then it passes. So those are certainly frustrating things that you really don't get with Cypress. You get screenshots and videos, so you can view screenshots taken automatically on failure of your videos for your entire test suite when you run them headlessly, so you can see screenshots of any failures that happen, and you get the entire video recording of the entire suite built in out of the box, which is just super cool. Built for scale. So Cypress has multiple ways to not the platform itself is built for scale, but they also have a dashboard product. So Cypress is a free open source tool, but they do provide additional pricing options for enterprise applications that really need to scale. Certainly you can contact them to get some of those pricing, but for the most part, you really don't need any of the paid things because Cypress it's used by over 11,000 organizations. It's used in over 15,000 projects. It has over 500,000 test run hours, and over 300 million tests have been recorded on their dashboard program. So with Cypress, with its dashboard, you can actually run parallelization. So if you have a test runner that takes, say, an hour to run, but if you parallelize that between, say, 4 servers, well, it'll only take 15 minutes then. So there's some really cool additional scalability options that it provides for your application if that's something you're interested in. One of the other amazing things that came to pass this last year, I think it was with 3.8, but Cypress has the ability to run tests across multiple browsers. Obviously, we have because Cypress is wrapped around the browser itself, so we have because Edge and all these other applications use Chromium now. We have support for Cypress with Chrome, Firefox, Edge, Electron, Brave, and more. I'm sure there are others, and more I'm sure will be coming as well. So awesome to see that. How you do that is when you open up Cypress, you actually see here, you can actually specify the actual browser you want to run it in, and it will run the test, literally open up that browser with your test scenarios, and it will run it. The other option is you can run it headlessly just by specifying using the browser flag and the name of the browser, or you can create a script in your package.json and set those browser flags as well. So here is what it looks like. Just to install Cypress, it's really simple. npm install it. It will then download Cypress. It will unzip it, finish the installation. You then just have to run open inside Cypress, and it opens up this Cypress test runner. You can then pick a single spec or run the entire spec, and it then opens up the Cypress the test runner, and it runs through every scenario that you wrote. Is pretty cool. So how does it specifically work? So I'll try to run through this quickly, but it basically works by leveraging jQuery. So we finally, after all these years of using jQuery for, in a lot of ways, really the wrong tool for the for the job. It really, in my opinion, is like the perfect use case for jQuery, where you get to use jQuery's powerful selector engine to make to select parts of your application in the DOM. Excuse me. And because it uses jQuery, for anyone who's done any type of front-end JavaScript development, the tests are going to be very familiar and readable for pretty much most modern web developers. So the way it works is Cypress uses subject management, and it uses promises. So you always create a new Cypress chain with the cy command. So cy dot and then a command, where what is yielded by the command, it establishes what the other commands can be called next. So you'll have some methods such as cy.get or cy.contains. It will yield a DOM element from the DOM, and it will then allow further commands to be chained onto them, like a click or a clear or type or something like that. One thing to remember is that Cypress commands do not return those subjects. So when you do cy.get and then instance here on line 1, input.post title, it doesn't return the input with the class of post title. It just yields that subject. Cypress commands are asynchronous and get queued from execution at later times. And so during the execution, those subjects are yielded from one command to the next. And a lot of helpful Cypress code runs between each command to ensure everything is in the correct order. And so with that in mind as well, because Cypress is using these commands and it uses promises, you can then just do .then to that subject to tap into that command chain. So pretty cool as well. So with that being said, we have these chains of commands. So to get more specific, it's very important to understand this mechanism because Cypress chains commands together. It manages a promise chain on your behalf, with each command yielding a subject to the next command until the chain ends or an error is encountered. So as a developer, you don't have to know everything about promises, but obviously some understanding of it works. So basically you establish some element on a DOM typically and create that as a subject, and then you interact with those subjects by chained on actions on top or onto that command, and it will continue passing through that chain until an assertion is made or an error is found. So here are ways you can interact with those subjects. So once a subject is established, so for an example like cy.get an input, you could then interact with that element by using .type or .blur, .focus, .clear. You could check or uncheck a box. You could select it, double click, right click, so on and so forth. And obviously assertions are an important part of any test to make sure that you're asserting that the element is visible or has a particular attribute, CSS class, state, etc. So basically assertions, in this case, you're just going to assert that the desired state of your application is what you expect it to be. So here, let's see what it actually looks like. So like any other test, you're going to create a describe command, which will sort of describe what this end-to-end scenario or group of tasks will do. Excuse me. So we describe, in this instance, we're talking about posting resource. So we use an it statement to describe an instance of this, where we're going to create a new post. So in order to create a new post, the end-to-end scenario is we're going to use the cy command to visit. So we're creating a subject of visit, which basically it routes the URL to /post.new. cy.get creates, we're doing this twice here, where we're getting a subject, two inputs. An input with a title of post, or a class of post title and a class of post body. So those two subjects then get interacted with by the type action, where you literally type. Well, you'll see the the test runner type in that control my first post and hello world. So you can see us creating a subject and then making or acting upon that subject. We're also using the cy.contains, which is a way of finding an element, creating a subject by finding an element in the DOM that contains that text submit. And then we're acting on that by clicking. So in this instance, we're finding a button that says submit, and then we're going to click that button. Creating another subject by using cy.url, and in this instance, we're then asserting that subject that says we want to assert that the URL will include posts / my first post. So we want to make sure that after we click this button, the URL at some point in it includes that string of text. And then we want to make another assertion by creating a subject of cy.get and h1 tag that should contain the string my first post. So that's an example of how you can create subjects, act on those subjects, down the chain, and then make assertions on what happens next. So here, this also is sort of this will look like when you open up Cypress, the files and what is found inside of your code editor. You'll see everything will be wrapped in a Cypress folder. Then it will have fixtures, which fixtures are used as external pieces of static data that can be used by your tests. These files are located, like I said, in the Cypress /fixtures by default, and you can change those obviously. And then your actual tests will run by default in the integration folder. You can then group them by groupings of of tests, and then specific spec files that actually run those tests will be found there. There are also additional plugin and support files, which are sort of just helper convenience mechanisms, so you don't have to import something like a file into every single one of your specs, because they can run before every one of your specs run. So let's look at some examples. So I have, let's see here. So I created I have an app. It's just it's a really silly app. It's just a Chuck Norris joke app. So I'm currently just serving this app as an Angular app. So if I do ng serve, you'll see if you can see it. I move myself. You'll see we're running this, and then if we do to run Cypress, we just do npx Cypress open. This will actually open the Cypress test runner, and you'll see from there. So we then have these Cypress folders up here. Let's see. Oops. Not sure if you can see this or not. So you can see here we have the Cypress folder with a fixture and 2 integration files. Pretty simple. Also created this helper command as well, which we can get into briefly. But here we see we ran the application, it's running, and we are running the Cypress app, and you can see it's pulling up here. And so all we have to do is we can run one of these tests individually by just clicking on it. It will then open the application up. And you can see in this instance, this application just literally loads 4 jokes from a Chuck Norris joke API. Something, if you want to see, we actually have you want to actually, so the actual application itself will run, it will look just like that. So if you just go to localhost 4200, it literally creates this, loads these jokes, and you can refresh them, and it loads new apps, new jokes. Pretty simple. It's a pretty trivial example, but it's an example. So here we ran one test, but if we go back to here to our Cypress runner, we can also stop this and we can run all the specs. And we can also see here, we can pick our different browsers we want to use. But if we click run all the specs, it will actually click through and run all the spec tests that we have. So in this instance, this indent scenario, we are literally making an API call to the API and returning them. So you'll actually get every time you run this, you'll get 3 different random jokes. We also have a stubbed instance where it's returning the same exact test every single time because we are stubbing this data. Because there's going to be instances where you don't want to hit, say this is a more complex app, and we had all these instances of things we wanted to test. Well, we don't want to hit our API 500 times. You can stub those results pretty easily, and I'll show you how to do that. So here we have, I'll show you how this is done. So we have, here's the API call. And so you'll see here, hopefully I'm going to zoom this in a little bit. Let me move this down a little bit. So you'll see here, we have, we're describing this, the Chuck Norris API. Before each, we're visiting this URL, and we want to make sure cy.loader, which is coming from, I created this command because this loader turns on and off every time it's loading new things, and I didn't want to continue doing cy.contains this thing. So all I have to do is cy.loader anywhere in my tests, and then I can run assertions against that. So this is just a helper thing that you can easily test. So before each test, I want to make sure this loader exists, it's on, and after each test, it should not exist. So this is just a easy way you can, without making these tests super verbose and long, you can test these things. So in this instance, we're making a request to this API. It's actually going to get the request, make a request, it's going to come back. We're going to expect the response status to equal 200. We're going to make sure that we have 3 jokes and with 3 images. So this is a way where we're testing what's on the DOM. We're testing the results from the response from this. So you get with Cypress an easy way where you can actually make end-to-end tests. You can test the responses, and it becomes very verbose in what you can do. But here is an example of, so I created a fixture called jokes.json, which essentially we are going to, as we would begin to create more and more tests for this application, we wouldn't want to keep hitting the API. So what we do is I took one of the responses I got back from when we actually make this request. I took one of those responses and just created it as like a stub data and called it fixture. So anytime we want to reference this fixture, it would only load these 3 static jokes every time. And so how we implement that is, so we have a describe where we're stubbing the results. We reference these fixtures, which Cypress sort of under the hood, it knows, it just looks for the prefaces of these files. So jokes, you don't have to do jokes.json. It just knows whether it be a .text file or markdown or JSON, it can find those. And then we set it as an alias by doing .as, and this is going to be our jokes response. We're going to then visit this like we normally would. We want to do the same thing where we make sure that loader exists. We want to make sure it doesn't exist. But in this instance, anytime you want Cypress to sort of intercept your network calls, you create a Cypress server like this, and then you create custom routes. So you'll notice this is the same exact route that we actually use to make this call. So what here we want to say is anytime we try to get something from, it's going to listen and intercept network traffic of gets to this route, and instead of actually making the request, we just want to return this jokes response from this fixture. So on every single one of these tests, it's just going to return back this jokes data. And then we want to make sure in this instance, we want to make sure that the length is 3 and the image is 3, but we want to actually make sure that that those 3 specific instances of those jokes are the same for every single time. So this verifies that this is actually getting back stub data versus the random data jokes that you get every single time you run it. And then you could continue writing more and more tests. We could go on and on all day on some of the cool things that Cypress has to offer. But for the sake of brevity, let's finish up here. I only have a couple minutes. So finally, there's tons and tons more things we could get into, but the one real final thing that I wanted to hammer away at is the documentation with Cypress, in my opinion, is maybe some of the best documentation of really any framework or platform that I've ever used. It really just provides great ways to get started. It really does a great job of presenting the core concepts, giving you guides, talking about the specific tooling, different references, as well as it also gives you some recipes of like how you tackle certain behaviors. So if you're really new to Cypress, it really gives you out of the box some great documentation on how to write your first test, and so on and so forth. So I highly recommend, if you haven't visited their docs, it's a great place to start. And certainly if you have any questions, it's a great place to search. And if you have any, any other questions, their team is really great about responding on Twitter. So people on their team, if you have questions, if you mention Cypress or some of their team members, they're really great at getting back with you. It's a great place to start, as well as certainly myself. If you have any questions about Cypress or how using it could help your company or solve the problems you're trying to solve, or maybe save some time, or whatever your case may be. I know for me, I just finished working with on a project where the company organization I was working with had a very I don't want to say archaic, but they weren't big believers in automated testing. And so the one benefit of using Cypress is they did a lot of manual testing. So because Cypress literally opened up in a browser and they could see everything that was happening, it gave them the confidence that the right pieces were being tested. So it's a little bit about me. You can find me on Twitter. My handle is JordanPowell88. GitHub, Facebook. I have a blog at jordanpowell.online, and it was great being able to share a few things with you guys. There's so much with Cypress, such a great tool, but hopefully you've begun to maybe scratch the surface on just some of the great things that Cypress can do. Love to answer any other questions you guys might have, and thank you for your time.
It says meeting is now streaming live.
Yeah, we are now live with all our friends who are watching us at JavaScript and Friends conference today. Thank you for speaking with us today, Jerry. And today we are going to ask you not some, but many questions to know what are your inspirations behind your startup journey and how did you get started. So we will take it smoothly and we will try to keep it informative for our attendees. So to get started, feel free to introduce yourself to our attendees today.
Absolutely. First, I would like to say thank you, Bhaskar, for having me. And I'm excited to share with the conference. You've been doing a lot of hard work. I know it probably isn't easy having to run this conference and do and wear the many hats that you do. So thank you, and we appreciate the work. And I'm glad to be here. My name is Jerry Valentine. I'm from Cincinnati, Ohio. Currently residing in Columbus, Ohio. I am a social entrepreneur, and I like to just, tackle problems. I like to just really think and challenge myself. So that's kind of what drives me as an entrepreneur, is just solving social issues and just putting my best foot forward, however that may be. So that's just a little bit about me. I am the founder of a year-old startup now called Renter Mentor, where we help connect people to affordable housing by providing a more secure and automated landlord-tenant process, as well as custom business automated solutions to businesses like housing agencies and community-based organizations that service the affordable housing space. So we officially have been on the record as a established business for only 8 months now, but I first pitched the idea back in April and have been working on it for a fairly long time, as far as probably about 2 years.
And so what was your primary inspiration behind Renter Mentor?
So in 2016, I started working at the Columbus Metropolitan Housing Authority. That is how I got introduced into the affordable housing market, that industry, and got my kind of, not only learned the business of what a housing authority does, but I got to really work with both property owners, tenants, developers, all different type of real estate professionals, and the players within the space. So within my first couple years, I was always hearing, the tenants, how difficult it was to find landlords that were out there in the space. And on the other end, I would hear property owners talk about like, hey, I want to, list my property on Section 8, which is the primary responsibility for these local housing authorities across the nation. That's what they do, is administer the Section 8 or the housing choice vouchers. So just hearing how difficult it was for the two parties to connect each other was what really sparked the curiosity to start my platform. And to give you, I'm not sure how knowledgeable everyone is out there about the space, but when you get administered a Section 8 voucher, essentially, you have 90 days to locate a landlord. So you're under a time constraint. And you would think 3 months would be a long time to locate, someone, but it's not, because with that voucher that you receive, it's a lot of, we call it source of income discrimination, where the landlords don't take the voucher, and nothing, even though this is a federal program, there was nothing there's no law that it says that, these property owners have to take the subsidy, because essentially there is more steps. It's very easy to just list your property for rent in the private market, get some hits, screen, and then move them in. With the affordable housing process it's a lot more different, because HUD, the housing, the urban development of housing, who is the general body of all these funds in these municipalities, they require a lot of things. Compliance, it's complicated. You got to do paperwork. We got to verify you. We got to check. We're in your business. Then you got to go through inspections. All these different things I saw in the space of just what made it complicated, and so I started doing my own research, looking into these different housing authorities, and seeing, well, maybe just the one that I'm working in, just maybe it's just behind the times or something. So I started looking, and I couldn't find, there was no solution out there that was providing a searchable database of voucher-friendly landlords. And I found that strange, because you have things like Hotpad, Zillow, Apartments.com. Is a plethora of essentially prop tech technologies out there that essentially does connections and property listings for the private market, but none that really catered. It's only one platform that's out there called GoSection8.com that is something similar, or tried to remotely be what Rent-A-Renter essentially is. But it's a lot of inefficiencies in that, lack of up-to-date properties. It's almost a predatory site of the space, where there was a lot of housing scams that go on there, which I heard a lot about within my 4 years at the housing authority. So the more and more that I kept hearing, and not just hearing, but also there were some processes that I could have felt could have been better. Just as being in this for my profession, that, I was like, why aren't we streamlining this? Or why aren't we, putting this information on our website so landlords will know? Because we were doing a lot of sending back. It's a lot of human error that was happening, because, really a lack of education on how to fill out these things. And if the demographic, like how I know the demographic in which we serve, which is the low to moderate income, there's a lot of barriers just outside of money that this demographic experiences. So whether it be, elderly or disabled, being, severely housing insecure, or just homeless, which brings along a lot of trauma in itself, or something, you got, like I said, elderly, disabled, veterans, basically a population that is very that is surrounded with a lot of challenges is essentially what we're getting here. And hearing these stories coming from not just the tenants but property owners as well, it was almost kind of like, okay, what can I do here? That was the spark of it, and it just so happened here, a local resource, where I was able to pitch the idea called Give Back Hack, which is a weekend hackathon. It's now global because of the pandemic, where you could be anywhere to pitch an idea and you don't have to be a quote unquote business person or this CEO. You can be a developer. You could be a business professional. You could be an accountant, whatever. You use that weekend because you can pitch your idea and you can generate a team. So I ended up pitching the idea April of 2019 as a solo individual at this competition, which was held at a local community, at a local college, and was able to get the team that I needed to form the first beginnings and win, some seed money and move on. So that's kind of how the whole startup journey for me started, and where the inspiration kind of sparked to do something in the space.
Cool. Because we know, like, generally entrepreneurs start creating solutions only when they are facing a particular problem, and you were able to notice that problem which is there out there in the housing space, and that sparked your thoughts, and it got rolled into what is Renter Mentor today. So while you initially started, right, because when you started, you might had you told about give back hack competition and all programs, but once you went into pitch into give back hack, and afterwards I think definitely you might be going to some sort of incubators or accelerators, right? So
Yeah.
within Ohio, because we will be hearing about accelerators, many accelerators are available outside of Midwest, but within Ohio, there are we are starting to see many accelerators and incubators. So what worked well for you, and what you want to share to us with respect to those programs which you are able to be part of?
That's a great question, and I actually love talking about this because really it's a huge component of what made our startup journey so special, was because it was really birthed from these community programs that were out here helping, and entrepreneurs like myself, kind of be great. Because before that, I also have another business of mine is I help charter a nonprofit called Get Out Network, where we do K through 12 STEM and art workshops for underserved, underrepresented youth. So that's kind of where, as a sidebar, where I get my drive for technology, STEM education, and things like that. Is really my drive to bridge the digital divide that we see. But before that, I bring all that up is because I was in the space trying to network and do things, and it was very hard. Granted, I depended on so much of my network to get things done, to build a board and all that with that prior business. But before that, it was a lot of just like, okay, dealing with meetings and things like that, where it was like, I can't build a team. It was hard to build teams. So what Give Back Hack in these hackathon weekends, what they allow you to do is to put yourselves in the rooms with all these different type of people with all these different type of skill sets. And so that's why I say you don't have to be an entrepreneur, you don't have to be a developer, you don't have to be a marketer. You can be whoever you are in that space, and whatever you want to do, you can do it, and you can attract other people to do whatever else. Or you can join a team. You don't have to be the one to pitch anything either. You can literally gravitate to an idea, which was what happened to me. I had 3 individuals that happened to make up the perfect components that I needed to execute a perfect pitch for that Sunday. So after Give Back Hack, what happened was we got a lot of traction. Give Back Hack is very established when it comes to the social entrepreneurial space and the social enterprise space, as well as the technology space. So we got a lot of kind of attention just from doing that, which led us to end up going straight into literally like 2 weeks later, we applied for a accelerator called C-Change, which stands for Social Enterprise Accelerator. So SEA Change. And it was 14 weeks and it was free. And there I was able to, do some more iteration, some more user validation to, because I'm still in ideation phase at this point. So Give Back Hack, I ended up winning $7,500 plus some in-kind resources to like co-work space, pitch practice with like some VCs, to really, more resources than I could have really handled at the time. Plus outside, when you win those, or I wouldn't say win, when you're awarded funding from those type programs, you also, when you go to these meetups and they're these other spaces that they host, you know, people start, hey, I heard you do this, and you know, So people that, you know, and you need that in order to develop your ideas, develop teams, especially in tech. You can't do this by yourself. So that's how I was able to gravitate more team members, iterate on some more ideas, do some more user validation. And then ultimately after that 14 weeks, win some more seed money and some more in-kind resources. So the traction was very high for us early. I'll say from April, the end of April, where I first pitched the idea, until September 11th of 2019. And I remember that date because the pitch competition was on the September 11th. We very much accelerated. And really didn't have time to, you know, during these accelerators, they're more so helping you really develop the business model, more so the product. So we had accelerated for almost 3 months, and it was like, okay, we've got all these resources, we got funding, we got people, you know, we got traction. That, you know, that want to talk to us, they want to learn more, they want to do this. And so for about 3 to 4 months, we accelerated. Then after September, I'll say from September until November, it was meetings, taking meetings. Like I felt like I went on a tour. Mind you, I was still working a full-time job at this point, because I had not resigned from the housing authority here yet. So I was still balancing all of this with the full-time job, and just trying to be as super productive whenever I could. I was even using PTO to go like, hey, you want to meet me at lunch? Yes. Hey, going to my supervisor, I'm calling off. I'll be back in 2 hours, you know, just to handle some business, because the traction, one, I had got the validation that I needed, that, you know, one, working in the space for 4 years, I knew there was a need. I knew there was opportunity. But to pitch it to people that weren't involved into the space was what got me. It was like, okay, people know that this is needed. And that was, you know, I got the validation. So it was a lot of meetings for 2 months after that. And after, you know, it was, so like I said, around November, at this point, I knew in order for me to sustain this, something had to give. Either I needed to figure out how to allow someone to run renter, or to do, you know, what a CEO could do, or I needed to resign. And I ended up resigning, and it's been one of the best decisions. After that, I reassessed, kind of like, okay, after all of those meetings, and it was a good thing because November enters the holiday season. So a lot of things were slowing down for businesses. Businesses were closing for the holidays and things like that. So it allowed me to really reassess, like, what resources do we have? What meetings did we already have with the people? And what can we do with all of this in a strategic manner to move forward? What, you know, to be honest, we started with consulting services. That was how I was like, okay, I can get paid for this right now, working directly with these landlords, and, you know, seeing where the pain point is for them, how to best automate these processes. Because at this time I had no tech players, actually. I'm not a technical person, as far as with all the skills and tools to develop software. I just was the idea man, and, you know, I know how on a high level what I wanted to do. So we were very much, it was like, well, with us not having any tech skills, what can we do to generate money right now? And that was the consultant services of actually onboarding and recruiting landlords, and, you know, educating them on the process, the landlord tenant law, walking them through the different compliance paperwork, the inspection process, And then ultimately turning in to get their subsidy payments through the housing authorities or other community-based organizations is what we did. So we piloted that for about a month. Then we closed down because of the holidays. And we wanted, take what we learned from, that month of working with the landlords that we were able to work with and the tenants, and wanted to really came up with the strategic plan to launch these consulting services for February, full going on. And of course that got pushed back, but about time we were ready, COVID-19 happened, which stopped the consulting services because we didn't know what was going on with the virus and things like that, and we were forced to stay home. But by that time, which was March of this year, through going back to your point of these accelerators, these programs, still very much, and I have a list of things that are resource or tools that I use in that gap time and between September and until about February, that really helped me develop my team that I have right now. Was after the accelerator, that again, sea change here in Columbus put me on another platform, especially within the social enterprise space. So we were popping. We were the kind of the buzzing startup here in Columbus that people wanted to talk to. They wanted to know more and things about, which was good because we were able to iterate on how we were talking about this, get more business ideas, possibilities, and things like that. But I started also within the midst of this because I was an entrepreneur. I didn't have to go into work. So I had now a whole week, that I needed to do. And the first rule that I'll say, if you're an entrepreneur, that you need to do, that first leap is, how do you develop a schedule? You have to learn how to keep your schedule looking like you have 40 hours of things, at least. That's the bare minimum. And of course, you determine that, which is the beauty of it all and what I like about it. But that is not, and it was, especially it was hard for me to establish at first because holidays happened. It was like, okay, as I was getting into the groove, because November 1st was my last, I had all of November to use Eventbrite and go to these meetups and go to workshops and to go, take up on coffee to all the people that wanted to learn more about Renter Mentor and we making partner and all that. But once the holidays happened, it outside of like holiday parties, it wasn't really, it was hard. So it took me almost a couple months to learn how to develop a schedule and to keep a full schedule and to keep busy. But in the midst of that month, though, I was able to really establish my roots with the Black Tech Columbus organization, who has been since the start of Renter Mentor, been very helpful and recruit. I wouldn't even say it was more recruiting. It was network and build a tech team of developers. Right now, I have a team of 7, and of that 7, 4 of them are on the dev team, 3 developers, including the CTO, and then our cybersecurity specialists that we have, just strictly focused on that because we're dealing with highly sensitive information with housing and then personal information, social security, things like that. So cybersecurity is key. So yeah, the accelerators out there and the hackathon weekends, they're there and they're helpful. There's a plethora in Ohio, ones that I have been privileged enough to go into and do. One was Startup Weekend, which I actually got access for free in like 2019 18, the fall of 2018. And that was my first hackathon weekend, and it was free. Grow by Google sponsored that. And for me then, it wasn't even to pitch an idea. I literally levitated to a team. I wanted the experience. I wanted to be in the ecosystem. I wanted to see what it was about. I wanted to be around more tech people. And I think that is the beauty of not only, accelerators and hackathons, but even conferences like, JavaScript and Friends. It's bringing, and a lot of people would look at this conference and be like, why is he speaking at a JavaScript? And that's for developers. A lot of people box in tech conferences and events just for tech, technical people. And that's not the case. And I even too had to get out of that, unconscious bias about it, and just like, well, even though I don't have the skills, I can still go into this room and see what I can bring to the table. And I think if nothing else, if you guys get this out of from this talk, is really whether you're a developer, you're an aspiring entrepreneur, you're in a C-suite, you're an entrepreneur. I was an entrepreneur for 4 years. Go into spaces that are untraditional, because that is how you grow. That's how you can see the understanding. What made building a business, this particular business, difficult was once we figured out the product and the services, that was easy. It's all about execution and getting the people, having the resources to bring that in. That was easy. It was really explaining the business so that in a manner that everyone understood, because we're juggling two big industries. You got technology, and then you have the housing ecosystem. Two opposites of the spectrum, really, because especially this component of housing, affordable, it's really public sector, so very kind of slow to innovate, slow to adopt technology. So when we talked about helping the tenants and they got that, but then when it was talking about how we wanted to implement technology and streamline processes and help connect, it was like, whoa, hold up, it was a bit too much. And then with the technologists, it was, we get the tech, we get the automation, we get the streaming, we get the connection, we get the technology. But then I start saying affordable housing, then it's like, why isn't this? And it was just a huge disconnect. So learning how to balance that, how you got to talk about it, and you got to see what questions people ask you, how they look at you, pitching the idea just at random times, at random things. That was the ultimate benefit. So the more feedback and the more iteration that you can do while you're in the ideation / early development phase, it was great. And not outside of just capital, we got a lot of in-kind resources. Co-work space, that's another great resource. We co-work out of COVA and Franklinton here in Columbus, Ohio, and they specialize in being they want to foster social entrepreneurs and social enterprises. So with being aligned in mission and things like that, they very much not only serve as a mailing address and a space for us to do business out of, but also a platform. They provide newsletters, they do social media blasts for us too, whatever we need. And if we ask, they'll figure out a way, providing different resources, like internships opportunities. That's been another, since we've started, I don't think I've never not had a group of interns that worked with us. And it's me. I know people hear interns and be like, woo, free work or whatever. And that's not how I try to take it. We've had some paid internships that were funded by third-party organizations that just needed, like this summer, we worked with an organization called Lead the Way, which was brought to you by Franklin County Franklin County Jobs and Family Services. So it was a workforce development program for high school youth. So we had 3 high school youth that interned with us and got paid for it by the county, $10 an hour. And it, at the startup phase for a high schooler, They did some market research, but I really wanted to give them an overall experience, a learning experience, and a good remote virtual experience. So we had speaker series, we had workshops being done virtually. They did virtual tours in these co-work space and things like that. So I know I'm going on the tangent, but I say all of this was because all of that spun out of going to Give Back Hack. And I would have not probably, really had gotten a lot of these opportunities and been in a lot of these spaces if it wasn't for that, initial kind of launch pad that Give Back Hack was able to provide.
Cool. So that was a lot of information for us to understand and relate with respect to the accelerators and the Give Back Hack program, right? So Columbus has got currently all these supporting programs, and it's good that you are able to share your experience from all these programs. And congratulations for your current release. I think we had some news out of your agency. So what tech stack do you use at Renter Mentor?
So yes, tech stack. Right now, Java. There's some Django in there. And like I said, I'm not the technical one. I'm just kind of going off of what I know. Very simple technology is essentially what is being used at Renter Mentor. I do not have the exact flow of it. I will try to pull that up before the end of the call to get the tech stack from Bakari. But yes, right now it's a very simple, because the technologies that we're using has been out, and really they're all enterprise solutions, but they're all open source. So we're not spending a lot of money on this technology, so definitely it's a very simply built platform. We built our database, first, and this is me learning how to build technology. And how we started building off and testing this thing was through wireframing. I'm trying to think, the Envision wireframing program, and just literally, basically, we thought essentially it was going to be a mobile app, but we were not able to. It was like, okay, well, the mobile app is more expensive, and it also brought more barriers within the population as far as, okay, can their phone download, us from the App Store, or, then we got to build the app in Apple or iOS and then Android. So, that's more across versus it's like, well, the basis of it all is a web platform. And then that is more, that'll make it easier. So that is kind of the strategy within using simple technologies for our MVP and our release that's coming in September to ultimately build up upon and expand, with more as our platform starts using more information, getting more data and things like that. So we are very, like I said, it's simple technologies with API friendly components to it, because that's the most efficient way to exchange information across platforms and services as well.
Great. That was a lot of information for us, and thank you for speaking with us today, and thank you for sharing your experience from the various programs and your journey of Renter Mentor with us. So if there is one advice, if you want to give someone who is starting newly, what will that be?
First advice is that you don't have to know everything, and you don't have to do everything. That I think that's big in the entrepreneur journey, is that especially building a startup, you can't do this alone, and you need to learn how to delegate, how to depend and lean on other people's expertise and knowledge. Number one. Number two is that you need to know your why. On why, before you do anything, pursue it, because that's ultimately going to be the drive that pushes you to execute. The more you are in tune with the why, and the stronger that it aligns with your ultimate kind of purpose and what drives you, it's going to continue to make you be resilient, because the startup scene it looks cool, but it's very hard on an entrepreneur. And you get told no a lot. You get people questioning your idea. You get people criticizing your idea. You get people that just don't believe in you. You get a lot of unfortunately, it could be perceived as negative energy. But in reality, it's just how the process just goes for building a business. And you got to know what is going to keep you, and what's going to keep you motivated and moving towards that ultimate goal, and whatever that goal may be, whether it's to, build a unicorn, whether to get acquired, whatever that is going to take work.
Cool. Thank you, Jerry. Thank you for speaking with us today. And I hope our attendees would have got some valuable insights from your talk. Thanks for joining with us today.
No problem, Bhaskar. Thank you for having me. Please, as a last word, follow us, Renter Mentor, on social media platforms. We're doing some really good things, and we're growing, we're building. We would love to, have, JavaScript and friends, really come out and just show some support, reach out, see how we can help each other. Like I said, it's these type solution, it's a community issue that we're solving here, and we're just trying to just do our part. And if you feel like you can help, and if I can help in any way, follow us on Renter. For Twitter, it's Renter, RENTER_MENTOR. And then LinkedIn and Facebook is just Renter Mentor. And then you can just follow me and reach out. That is essentially, that's a tool, a hidden tool that I rediscovered during this quarantine, was Twitter. And that's ultimately how me and Bhaskar kind of connected to make this happen. So JerryV513_ on all social media platforms. Follow, and just see, you don't necessarily have to look, I'm trying to be on the team, which we're here to open to that. But if it's just, hey, I've got a business idea, or I got resources that I may have or I may need, I'm here to just talk and see where the synergy is. So thank you for having me, and I appreciate you all time. Thank you.
Thanks.
There we go.
All right. We are now live. We will give like 3 more minutes, and then we can get started. All right. Thank you all for joining us today, and hope you had a nice conference. And I was gradually monitoring all the chats and all the uh, interactions which we were having over here, and nice to see the community getting together. And with that said, I don't want to take more of your time. We would like to thank all our sponsors. We would like to thank Circle CI, Lightstep, MySQL, Weekend Code IT, OutSystems, Precise Resource, Manning Books, No Starch Press, Do It Clean, and Calibrity for all their support. And secondly, we want to thank all our speakers. Without you, this day would not be possible. So we thank you for delivering us your talks and bearing with us and providing all the recorded talks. So thank you for doing that. And we thank all our attendees and everyone who is involved in making our second year awesome. We thank you for your support. So we have few giveaways. There is a giveaway from Circle CI. If you are able to see the bit.ly URL, you can use this to participate in the raffle provided by Circle CI. And you can also participate in the raffle of a book giveaway by Lightstep. Feel free to participate in that raffle as well. And if you are checking the hallway conference Slack channel, we have posted a poll. So we will be giving out or picking winners from the poll to be considered for $25 Amazon gift card. You know, I'm very tired, right? And one No Starch Press ebook voucher, which is of value $20, and one e-course, which is of value $25, and that e-course can be of your choice. So once we pick the winners, we will reach out to you.
To be fair, you can buy a Kindle single for $1 on Amazon. So.
Right. But we want to support the content creators, right? So that's the primary reason of doing this. So all the conferences and learning opportunities will not happen until there are content creators. So we need to support them. And this is one way we do that to support them. So and if you're still watching us live, or if you're going to watch this at a later time, we will be sending email survey where you can respond to us with your feedbacks. Please share your feedbacks. And if you are live now, you can always share your feedback in the Slack channel under Conference 2020 Feedback. And you are able to see 4 friends over here, and I thank them for their support. And with them as well, we have many people behind the scenes who are helping us. So we would like to thank for the content which we are seeing today. All the talks and everything were selected by Barrett, George, Greg, and Matt Eland. Thank you for selecting or putting your time in selecting these awesome talks. And from operations, we have Brandon, and we have Kendra, and our volunteers who have joined to help us on this conference day and workshop day. And we would like to thank all who have helped us in contributing to the website. Dharmashri, Joel Lord, and Ted, you both made some cool PRs, and we have merged it into our repo. We would like to thank Christine and Ryan for being always there for us with respect to the website. And I would like to thank especially Michael Jolly for the stream layover design. So the cool blue background layover, which we were seeing in YouTube, was designed by Michael Jolly. And most of the streaming inspirations, I have taken it from Hank Bollman, Signal Nerve, and Martin from their blogs. And I really miss our friend Calvin, who was streaming, and some of his experience I have taken from him as well. And I would lastly, I would want to thank Saduki, our community champion today, for helping us out in a great way. Thank you, Sarah. And now if you want to tell a few words, the floor is yours, friends.
Yeah, I just wanted to say, what similar to what Bhaskar said, thank you guys so much. Everybody who, sent in talks. I said this in a couple of the channels, but I think our talk lineup this year was one of the best I've seen. And that's all thanks to you guys and the work that you did and what you submitted. And then thanks to everybody who attended and for everybody who helped to volunteer with the way that things turned out to be this year. Obviously we weren't expecting in our second year that we would have to completely change the format. So having the support and the enthusiasm that all of you guys showed was absolutely critical to help keep us going. And because of all of you, we're definitely going to be back next year again, and we're very, very excited about it. So just stay safe and stay healthy, and thank you.
Yeah, I just wanted to add my thanks as well to everybody for their support this year. Like Brandon said, this being our second year and having to completely change things midstream and having to rework the format so that we could still have a conference this year and keep going with our passion project here. And just grateful for everybody's support and everything that's happened, and hope to see you all in person next year.
I'll be brief. This conference was awesome last year. It really changed me significantly, pushed me in some very good directions. I was honored to review the submissions this year, and there was not a single one that I wouldn't have loved to see. I couldn't catch much of the conference this year, but I'm looking forward to catching it on YouTube. I do want to thank Bhaskar just for heading all this up and just for this idea and pushing it forward to serve the community.
Thank you all. I forgot to mention our diversity coordinator, which is Lacey Nichols. Thanks to Lacey as well for all the diversity champion activities for us. So with that said, thank you all for joining us this year and making our second year awesome. We would like to see you next year, and we hope the situations will improve and it will be an in-person event next year. So if you have liked the talks, or if you have anything you want to share, you're always welcome to share your feedback with us. Now, please go ahead and subscribe to our YouTube channel. We will be publishing monthly remote meetup talks in our channel as well. So all our speakers are always welcome to speak in our meetup group. So you are always welcome to reach out to us and speak remotely. And that's one of the advantage we are taking with respect to the remote situation now. Yeah. Thank you all.
Thanks.